এই ইউটিউবে লাইভ হয়ে গেছে।
Sir, now streaming on YouTube. Sir, now streaming on YouTube.
ওকে, আমি তাহলে অ্যাডমিট করে দিচ্ছি। হ্যাঁ,
Okay.
দেবেশবাবু, ভ্রমর মুখার্জি থাকবেন, প্রফেসর ভ্রমর মুখার্জি, মিশিগান না?
হ্যাঁ, ভ্রমর মুখার্জি হচ্ছে মিশিগানের স্কুল অফ বায়োস্ট্যাটিস্টিক্স এর আছে ও
অধ্যাপক। হ্যাঁ,
ও এখন চেয়ার, ডিপার্টমেন্টের চেয়ার। আর একজন থাকবেন স্কুল অফ ট্রপিক্যাল মেডিসিনের প্যাথোলজির হেড, ডক্টর প্রণব ভট্টাচার্য।
ডক্টর প্রণব ভট্টাচার্য, আচ্ছা।
উনি ফার্স্ট স্পিকার হবেন।
হ্যাঁ হ্যাঁ,
ফার্স্ট স্পিকার হবেন, আপনি ফার্স্ট স্পিকার, তারপর উনি সেকেন্ড স্পিকার।
হ্যাঁ, বুঝতে পেরেছি। মানে আমার তো আপনি ডেকেছেন নিয়ম রক্ষা করার জন্য, আমি আপনি নিয়ম রক্ষা করব আজকে।
না ভিসি স্যার, আমরা একটু আপনার একটু বেশি কথা শুনবো আজকে।
হ্যাঁ, কেন? আজকে তো ভালো।
আমি আপনার জন্য আধ ঘন্টা রেখেছিলাম বলে সবাই বলছে আমাকে ভিসি স্যার আধ ঘন্টা ভিসি স্যার হবে না, একটু বেশি সময় দিতে। আমি বললাম না, উনি ব্যস্ত মানুষ।
আমার যে বয়স হয়েছে এটা আমি বুঝতে পারি যখন এই আপনার কিছু জায়গায় বলা। হ্যাঁ, আগে বলতাম ৫-৭ মিনিট ১০ মিনিট, এখন আমার এই মাইক পেলে না, আপনারা ফোরাম দিলে তখন মনে হয় বলেই যায়। খুব ভেরি ব্যাড হ্যাবিট।
না না না,
আমাদের তো খুবই শুনতে ভালো
লাগে। আমরা সেটাই চাই তো।
থ্যাংক ইউ।
Sir, please start now.
আমি আর একটু জয়েন করে নি।
Sir, now full.
হ্যাঁ, 97। তোমার রেকর্ডিং কমপ্লিট? রেকর্ডিং সিস্টেম রেডি?
Yes, sir.
ওকে অরুণদা।
হ্যাঁ,
তাহলে শুরু করব?
হ্যাঁ শুরু। কতজন ঢুকেছে?
হ্যাঁ, আমার ফুল হয়ে গেছে, জুম ফুল হয়ে গেছে, এবার ইউটিউবে বাকিরা চলে যাচ্ছে।
ইউটিউবে যাবে, আচ্ছা ঠিক আছে।
Good afternoon, everybody. Honorable Vice Chancellor, the Principal of Barasat Government College, other dignitaries, and the participant. Our two eminent speakers will join soon. It is a very pleasure to all of us that we are going to organize the first international webinar of Barasat Government College on surviving in a COVID world, major issues of India during this most unwelcome lockdown period. I, being the convener of the webinar, formally announce of starting our activities. Before starting this, there are 2 or 3 small announcements. First, I am very happy to announce that we have more than 2,000 registrations from different corners of India and abroad within a very short period of notice. Second, participants are both in Zoom and YouTube platform. Both are live streaming, so please stay mute during the program for smooth conducting. All you are requested to use chat box or any type of query, including question. We will collect your question in time and send to our speaker or concerned person. We are using licensed Zoom software, so all are requested, please don't use email, phone number, etc. during chat. Third, during the program, we will get feedback from after the second lecture. And after getting feedback, we will issue e-certificate tentatively in the last week of September. So this is all from me, and I am no more. Now for welcome address, over to Professor Dr. Devesh Roy, Principal of Barasat Government College. Sir, please.
Good afternoon, everybody. My role is to welcome everybody present here. The COVID-19 pandemic has infected nearly 26 million of world population. Death toll has surpassed 6.8 million across the globe. The first case of COVID-19 in India was reported on January 30. And as on today, the total number of confirmed cases has crossed 3.8 million mark, with more than 67,000 deaths. The number of daily infections are also increasing day by day, though at a reduced rate now. And within next 2-3 days, in respect of total tally, India is likely to surpass Brazil. Had we been able to capture the total number of unreported infections, we could have been possibly the topper in the world in this respect. The impact of pandemic is visible across the sectors globally, but its impact on marginalized sections, women and children, have been immense in India. This crisis is going to affect economy as never before, leading to massive psychosocial impact as well. Social stress caused by lockdown has many faces and reasons, resulting from traveling restrictions and disruption of cultural celebrations, limited healthcare facilities, and interruption in regular immunization program in hospitals are leading to the anxiety and fear among the common people. Social distancing with friends and family, closure of places of entertainment, unplanned closure of schools and colleges are affecting both students and parents alike with the apprehension of losing academic year. Inadequate infrastructure leading to ill-equipped healthcare facility are affecting the employees who are fighting endlessly to treat patients. In this backdrop, the Barasat Government College has planned to organize today's discussion session under the title Surviving in the COVID World. All of you are aware that Professor Bashop Chaudhuri, the Honorable Vice Chancellor of West Bengal State University, the affiliating University of Barasat Government College, will give his keynote address today. He is already with us and does not require any introduction. May I welcome you, sir, on behalf of Barasat Government College. Your presence has really added to the glamour of the program today. Thank you, sir. Today's second speaker is Professor Pranav Bhattacharya. He is a professor and HOD of the Department of Pathology in the Calcutta School of Tropical Medicine. The title of his lecture is Aetopathogenesis Pathology, Clinical Features of COVID-19. The title of his lecture is, I have already told the title, Aetopathogenesis. I am not aware of this topic. Professor Yukto Adhikari possibly may enlighten us about this. Professor Bhattacharya has more than 300 publications in different international journals of high impact factor that include journals like Lancet, The Science, among others. He will be introduced by Professor Yukto Adhikari, our HOD of the Botany Department, before his lecture. However, Professor Bhattacharya is yet to come, and I hope he will join us shortly. The third and the last speaker of today's program is Professor Brahman Mukherjee. Professor Mukherjee is the John D. Kalfleisch Collegiate Professor and Chair of the Biostatistics Department and Professor of Epidemiology of the University of Michigan at Ann Arbor. She will be joining within a short while with us. Today, so many members of the faculty and different institutions have joined with their students in this platform. Their participation will enrich us and add additional glamour to this program. On behalf of Barasat Government College, let me welcome all the participants and request them to participate actively in the questionnaire session. With these words and with all good wishes, let me conclude now. I will come back again on a different purpose. Thank you all for the present. Over to Chandan.
Sir, please unmute yourself. Sir, please unmute yourself from your end.
Now I would request to our Honorable Vice Chancellor, Professor Bashop Chaudhuri, for our very short keynote address.
Good evening to all of you. Can you hear me now?
Yes, sir.
Yeah. Good evening to all of you. Respected Dr. Chandan Surabhi Das, who is coordinating this program so efficiently. My respect to him. My respect to the principal of the Barasat Government College, who is also a member of the Executive Council of the university, and perhaps of the court also. No, of the Executive Council of the university that runs the university basically. So he is the authority he is one of the authorities of the university, and as principal of the Barasat Government College has been doing a commendable job, and also does a lot of good work for the university. I am indeed grateful to him. All the respected teachers of Barasat Government College, which is a well-known college, one of the best colleges of the West Bengal State University, and it is my pleasure to be associated with the college. After Professor Debesh Roy has joined, this college has really remarkably improved in terms of academics and administration. So my respect to Dr. Debesh Roy. My respect to uh, the speakers, Dr. Pranab Bhattacharya of the School of Tropical Medicine, who will speak on pathogenesis, as we have heard from the respected principal of the college, and Professor Brahman Mukherjee of Michigan State University. He is the chair. She is the chair, right? Or Professor Brahman Mukherjee is a gentleman, right?
Professor Brahman Mukherjee is a lady.
Oh, okay, okay.
Is a
Professor Brahman
lady.
Mukherjee. Okay, okay. She is now the chair of the Michigan State University, and as I heard from the respected principal of the college, she was one of the students of Professor Devesh Roy, and has done extremely good work in the area of biostatistics. Now, all of us know our situation. All of us are aware of the pandemic. All of us are aware of the lockdown that is going on. Now, in the month of November, sometime in one of the newspapers, I heard this COVID-19 or things like SARS-CoV-2. And someone said, Wuhan province and in China and things like that. I did not care about it. I really did not care about it. If it happens, so many viruses are coming and going. So what is the point in getting partnered with the virus? So I did not really give any importance to that November story. It came in newspaper. Then in the month of March, first week of March, I think it was 1st March, one of my friends told me that the country will soon go to lockdown. I laughed at him. He is associated with a very big company. He said that, okay, you laugh at me, but the point is you get ready because everything will stop for the next 6-8 months. I said it is not possible simply because this country is having 130 crores of people, and out of 780 crores, it is 130 crores, means every 1 in 6 is an Indian. Many people are having livelihood on the basis of ordinary jobs, regular jobs. So it is simply not possible. I am not believing you. He just laughed at me. Then I laughed at him. He laughed at me. But finally, laughing at really became reality for him, and I was the laughing stock. When it happened, he said that my company knew this. We have good business with different other companies, very big company. I am not naming. So he said that we were preparing for this, and this is what has happened, and we are not supposed to go to our workplace without any permission for the next 6 months. Then, one day the respected Prime Minister, Honorable Prime Minister of the country came and said that, on one Sunday, I think, that you please stay at home. So that was fine. Then, then 2 weeks lockdown. That 15 days was very good. 15 days, a period of 15 days, that was good. People were really having very nice time. After that, we started feeling that the SARS-CoV-2 is indeed a dangerous virus. Quite dangerous. Before SARS-CoV-2, we had the severe acute respiratory syndrome virus in 2003. At that time, we did not have any problem. We had regular office going and everything was happening. But the death rate was very large during that time. 10 people out of 100, I think, that were 10% people were dying. Then came MERS, Middle East or respiratory syndrome or some virus. That came in 2012, 2013. That was also not very bad. But the death rate was very high there also. I mean, reasonably high there also. This SARS-CoV-2 does not kill many. But what it does is it infects, creates a fear psychosis in human beings, creates a pressure on the healthcare system, destroys the healthcare system systematically. and then leaves you in a kind of lack of confidence mode, where you always feel that you will be infected if you go out. So it does a very great harm, and we could understand that in the last 6 months we have been in a period of lockdown, and thank God it should not happen to any country anytime, in this manner, to the world in any manner. As has been stated very properly, all of you know better than me that even during the Second World War, so many countries were not affected as SARS-CoV-2 has affected all of us. So that is basically the situation. It is the infection is so very high that if you go near to people, and if you do not use mask, if you do not use gloves, if you do not follow this PPE kit while working, it may infect you. So that is what my daughter is a doctor. My daughter is doing COVID duty. She's not here. She has gone to Emar Bangur Hospital. She's now in Emar Bangur Hospital. She is in charge of the floor. She is telling me that indeed the rate of cure has improved drastically. Rate of cure has been very good, and people are going for 2, 3, 4 days. After that, they are feeling, when do I go home, because they are getting well. But the point is, the fear psychosis is still there. That, if it is infecting in Hong Kong, the second infection has taken place. Second time the person has been infected by SARS-CoV-2. That means initially there was an infection, he got cured, 2 consecutive tests, there were nothing. Then again he got infected, but this time it is asymptomatic. Earlier it was symptomatic, now it is asymptomatic. This SARS-CoV-2 virus, this all of you know that it has those spikes on the head, on the surface. It is just like a small spherical ball, and on top of that there are pins, just like pins, and those pins are protruding out, and those pins are sitting on your epithelial cells, going into your system. And I hear from my daughter that the last stage is kidney failure. Kidney failure is happening, and none knows exactly how it is happening. A kidney failure is occurring, and because of that dialysis, and then that person is collapsing. So it may be due to something else, it may be SARS-CoV-2, but the point is that now it is being seen that SARS-CoV-2 is really causing a lot of problem. I do not know, in the month of January, my wife had a very peculiar problem. She had vein problem, tremendous vein problem. She was not in a position, she's a very active lady, but the point is the kind of vein problem that happened. Now I feel whether it was also due to some virus, or that not, it was tremendously debilitating. Almost she was sick for 15 days, and did not know how it happened. And my daughter was treating her. At that time she did not complete her MD. She completed her MD only in month of June. So at that time she had her studies, but she did not know what to do. I now feel that these are all manifestations. Maybe at that time only the virus had been spreading its wings and causing problems. So these virus, as the respected principal has stated very clearly, has infected a large number of people, killed a substantial number of people, but it has created the most important thing, that is fear psychosis. What kind of fear psychosis? Everyone feels that I may be infected. Everyone is having, in our Bengali household, we have our mother, we have our father, old mother, old mother-in-law, old father-in-law, someone old, someone sick, and we do not want to go near them. Today in the Times of India, I was seeing the kind of treatment that we are giving to our doctors. One doctor has written that these they are not COVID warriors. He has compared the doctors and nurses with the soldiers, and they say that these doctors and nurses, these people, they are fighting this, taking care of these patients, and they are fighting COVID. But the point is, without any return, without anything in mind, they are just doing their job. So my point is that we are really in a state of pandemic, and the pandemic is so very bad Dr. Bhattacharya, Professor Dr. Pranab Kumar Bhattacharya has joined, and I'm so happy to see him. This pandemic, as has happened, it is really, it has left all of us with some kind of fear psychosis. We do not know what to do. In spite of that, we see that in this state of West Bengal, in spite of all the criticism that you hear, doctors are doing a great job, administrators are doing a great job, police administration is also doing a great job, politicians are doing a great job. We see the honorable chief minister going to office every day and trying to take care of the thing. It is a popular state, and all of us know how difficult it is to control this pandemic. Only through education, only through self discipline, only through restrictions imposed upon oneself through the guidelines, it is possible to avoid infection, and it is possible to not to give infection to others. So that is what it is. That is what SARS-CoV-2 has taught all of us. It has also taught us that anytime the human civilization, we talk about this, that we are very powerful. We always feel that we are very powerful in spite of all sciences, everything. See, vaccine development is still not an easy job. In spite of all biology, in spite of all understanding, it takes time. You must give time. So doing cutting edge research is very important. Research should not be copycat. I always say this point to my friends and to my students, and I have always said to myself that even if you publish one paper or two papers, Einstein did not know, was a nobody basically. How he came up with those theory of relativity, no one understands even today how a novice could come up with those things. Point is, it is extremely difficult to develop a vaccine. Vaccine research is a very arduous kind of strenuous job. One needs to do experiments after experiments, do trials on animals, do trials on next generation of next group of subjects. After that, human trials. After the second human trials, third human trials. If there is any side effect, all these have to be done, and the respected doctors are already doing all this. So many doctors have died by taking care of this COVID-19. In Shamnagar, I heard a doctor that his chamber is not very good. It does not look very great. His chamber was very ordinary, and he used to say to his friends that poor people will not come to my chamber if I make it very great, if I make it very state of the art. His chamber used to attract a lot of people, but he died of COVID-19, SARS-CoV-2, because he used to treat these patients. They are heroes. They are heroes by any means. They are people who are taking care of all of us. It is not that my daughter is a doctor and I am saying this. The profession of, that is the noblest profession. Profession one is in doctors. After, doctors and teachers, they are people who should be respected by the society at every time, under all circumstances. Point is, under this getting a feel of the human civilization. Human civilization, is very young. It is a 10,000 old civilization. Industrial revolution came only 300 years ago, 1750. Not even 1750. So it is 250, 270 years. So in 270 years, we have seen steam engine, we have seen development, we have seen computer coming in 1940, we have seen PC coming in 1980 or 1970. Then smartphone smartphone coming only in 1990. And then these mobile technology, and then internet of things, they have really changed our vision, our world. But in spite of that, see how nature can play havoc with our lives. How nature can play havoc with our lives. There must be a limit to everything, and we cannot do much by doing tinkering with nature, by doing tinkering with nature. Nature has its limit. Everything has a limit. Nature has its limit. There must be a limit to growth. The Club of Rome in 1960 used to say there is a limit to growth. So limit to growth is also important. And I do not know how SARS-CoV-2 came. I do not know whether Wuhan had a laboratory. I do not know whether from the animal pangolin it has come to our from bat pangolin it has come to humans. I do not know about all these because the biologists are the best persons who know. My subject is not biology. My subject is chemistry, applied chemistry. So I will not comment on all these. My point is we need to be extremely careful when we really play around with nature, because if we are cutting trees, we are creating problems, air pollution, water pollution, soil pollution, playing with biodiversity, playing with things ultimately leads to this kind of thing where a virus has been staring at our eyes, and the virus is saying that human civilization you are talking about, see, viral civilization is also not at the back. It is the viral civilization that is defeating the human civilization today. But then what is the answer? The answer is, the creativity of humans is something great. Humans have done it again and again and again. In spite of everything, the humans have really come up. But we must be careful. I was reading some article in Current Science, and there some very distinguished biologist said something very interesting. That editorial was on insects, and he said that if the world of insects are totally eliminated, we will not get back the world that we are existing. But if every human being is destroyed, it will take only 10,000 years to develop the civilization. The point is that we must be careful about our environment also. We must take care of our environment in order that the environment is not degraded substantially further. That is one point that must be taken note of. And the statistics, this epidemiology, how the different people are getting affected, why a particular virus is causing this problem, how can we take care of this virus. We were not at all prepared with the threat that this virus SARS-CoV-2 has done to us. So we must be careful, and we must teach ourselves how to take care of us. That is one thing. How will education proceed? We cannot go to our classrooms. We cannot do anything. Classroom teaching is the best form of teaching. We must say that again and again and again. But when we cannot go to classroom, we must develop new technologies. We must have new processes and products. We must have internet so that students can be reached. The academic year is not lost, and that is what the Barasat Government College is doing. And all the students and all the researchers and all of you 2000 participants who have registered for this particular webinar, they are in a position to hear the good lectures. Those who are not hearing the good lectures, Professor Bhattacharya and Professor Mukherjee, one from our Kolkata and the other from Michigan, these lectures, kindly keep notes and kindly circulate these notes to your friends and colleagues so that you can become COVID warriors in a different sense. How? You are spreading knowledge. You are becoming COVID warriors in a different sense because you are spreading knowledge. I attended a webinar. That webinar was on this particular subject. Professor Pranab Bhattacharya and Professor Brahman Mukherjee spoke over there. Their message was there. Professor Devesh Roy spoke over there. That message was there. Dr. Chandan Surabhi Das coordinated the program. His message is this, and I am telling you, this is the knowledge that should go to your peers, to your students, so that to your friends, so that you can become COVID warriors by spreading the knowledge disseminated through this webinar. In that sense, you are also a COVID warrior. You are also trying to fight this COVID-19 SARS-CoV-2. So that is what I just wanted to say. I am not a biologist. So the point is, Professor Bhattacharya will be the best person to speak. Professor Mukherjee will be the best person to speak because they are working, they are on biostatistics, they are on pathogenesis, they are on epidemiology, they are on, how this particular virus is spreading its head, how the epithelial cell is getting affected, how it is going into the lung and causing, the lung tissues are getting affected. So they will be able to say all these things. My reading is very, very sporadic. I am not a biologist, and I always believe that discipline specific reading is very important. One must be discipline specific, because unless you understand a discipline, it is always a little learning is a dangerous thing. So you should not propagate knowledge. You should be very careful. Unless it was said by Richard Feynman. Richard Feynman is considered to be the greatest physicist the 20th century produced. He got Nobel Prize in 1965 on electrodynamics, and by far the best physicist world over. There are many books, and there is a book called The Pleasure of Finding Things Out by Richard Feynman, and I quote that book many times. Richard Feynman had said to his students and friends that never agree to deliver a lecture unless you know what you are talking about, and unless you know what you really understand. Unless you understand the subject, do not try to talk about it. So Professor Bhattacharya and Professor Mukherjee are the persons who will speak, and we will listen. My problem is I cannot listen because I have to speak and I have to do administration. I am a total administration man today. I am an absolutely administration man today, and if you take away my administration job, I have no job. Simply because I have been doing this academic administration for the last 13 years, right from Calcutta University to this university. And Professor Devesh Roy knows, and I was telling Professor Devesh Roy that what do I say other than welcoming the great speakers who will speak this evening. So that is what I just wanted to say. My regards to Professor Bhattacharya, my regards to Professor Mukherjee, my regards to Dr. Devesh Roy, Dr. Chandan Shrobidas, my regards to every student. Student is God to me. Under all circumstances, it is because of the student that I exist. It is because of the student that Dr. Devesh Roy exists. Because if the students do not come to the university, what is the point in having the university? So that question is also important. There is no point in having a university unless the university attracts bright minds. The university will attract bright minds. How? Our job is to facilitate good research and good teaching. We are not doing directly teaching and research, but we are trying to see in our university that a student really willing to learn is not getting any obstruction on his way to move. If they can come directly to my office anytime. My office is always open. So anytime there is no appointment, nothing. A student comes when student has the highest possible, opportunity to come to the highest, the person who is in charge. The student will come, the student will speak, the student will give his complaint. The student will say that you are not doing a good job, Vice Chancellor. That is what, I had little bit training in United States. I had little bit. And one thing that I learned is that, this society should be very open in the sense that, there should not be this British system that I cannot go to that man. Yes, you can go to that man. You can speak to that man. That is what is important, that transparency and that system should be in place so that we know what is going on. So I am indeed grateful to all of you. I'm indeed grateful to all of you. I'm indeed grateful to the Barasat Government College. I'm indeed grateful to all the persons who are on this webinar. Grateful to the principal, and grateful and privileged to have had this opportunity to reach you. I have tried to give you a little bit of sketchy information that is available, that perhaps everyone knows. But my objective is to pay respect to the two professors who are here on this platform today. And I know that they will do a fantastic job at the end of the day and 2 days. And I'm sure that this webinar will be very successful. My thanks to Dr. Chandan Shrobidas, my thanks and gratitude to Dr. Devesh Roy, and to all of you for giving me this opportunity to convey my message. Thank you. Stay safe. Take care of your family, take care of your friends, take care of the neighborhood, take care of the world. Sarve sukhina bhavantu, sarve santu niramaya, sarve bhadrani pashyantu ma kaschid dukkha bhave. That is, that is the message of Lord Buddha. Sarve sukhina bhavantu. সর্বে সন্তু নিরাময়, সবাই সুস্থ হোক, সবাই সুখী হোক। That is what it is. So thank you very much for giving me the opportunity. There is another webinar, I have to go now. So that is what causing me problem, Dr. Das. That is what is causing problem. So thank you very much that you gave me this opportunity. Thank you. Dr. Professor Bhattacharya, my regards to you. Professor Mukherjee, my regards to you. Dr. Devesh Rai, my regards to you. Thank you so much. Thank you so much.
Thank you, sir. We are taking your advice in the right spirit. We have got
Thank you.
today. Thank you,
Thank
sir.
you. Thank you. Dr. Roy, thank you. Thank you, Professor. Thank you.
Thank you, sir. Thank you, VC sir, for your very excellent message.
Thank you, Dr. Das. Thank you. I don't know whether it is excellent, but the point is you forced me, so I had
No.
something to say.
Yeah,
Thank
really
you.
means, sir, the time has come for rethink the concept of limit to growth for our sustainable environment.
Yeah,
for
leave it to growth. Yeah,
education.
yeah, yeah.
Yes, yes.
Sustainable development. That's right. That's right.
Yeah.
Thank you. Thank you. Thank you.
Thank you. Now, I would like to invite our Professor Dr. Yukta Adhikari. Sir, শুনতে পাচ্ছেন? Am I audible?
Yes, yes.
Yes. Sir, please, our next speaker, Professor Pranab Kumar Bhattacharya present. So, before going to our lecture, I would request to Professor Adhikari for a brief introduction of our eminent speaker. Please. Please, sir.
Thank you very much, Dr. Chandan Surabhi Das. Good evening, everyone. I would like to express my deepest encomium to our honorable principal, Professor Devesh Rai, for providing me with the opportunity to introduce an eminent speaker, Professor Pranab Bhattacharya of Calcutta School of Tropical Medicine. I'm also thankful, although I'm a faculty member of Barasat Government College, but I'm specifically thankful to the organizers of this webinar, international webinar, where two eminent speakers have come over here, and it is my responsibility to introduce Professor Pranab Bhattacharya within 2 to 3 minutes. It seems to me very difficult for me to introduce Professor Pranab Bhattacharya within 2 to 3 minutes because his work is immense and he's a special type of scientist and doctor who works silently, coming out with outstanding publications and communications, but his entire participation is very, very silent. I used to go to Calcutta School of Tropical Medicine almost frequently since the last 7 or 8 years, being member of Calcutta School of Ethical Committee members, Animal Ethical Committee members, and other reasons. So far, I can remember that Professor Bhattacharya was introduced to me in the year 2013. And however, we do not have direct contact regularly, but I have heard about him. And to have him in our webinar, I am thankful to one person who may not be present here. She is Dr. Sujata Law of the Biotechnology Department of Calcutta School of Tropical Medicine, who helped me enormously to have the consent of Professor Pranab Bhattacharya to be with us in this evening. Regarding Professor Bhattacharya, I shall take only 1 or 2 minutes regarding his CV because his CV is very, very long. And if I would like to express his quality of teaching, quality of research, quality of publication, it may be a mini seminar at least. That I should avoid. So I'm just summing up within 2 to 3 sentences. First one, Professor Pranab Bhattacharya is a very, very eminent professor in teaching and research. And he's the chairperson of the Department of Pathology. And you know that Calcutta School of Tropical Medicine has an outstanding history in clinical research. You can have the information from the website of CSTM. But regarding Professor Bhattacharya, so far I know, because he is always very, very reluctant to provide a very long CV to anyone. I've got a very brief CV and I've come to know from some of his colleagues. Actually, Professor Bhattacharya is an outstanding person in the field of pathology. Not only today he will talk about COVID-19 or coronavirus, but he is a very dynamic person. In the year 1981, he obtained his MBBS degree from Calcutta Medical College, the most esteemed one, followed by his MD from IPJ Mir SSKM Hospital in 1989. And thereafter, he obtained several degrees from several international institutes and universities. And at present, he has nearly bagged more than 300 publications and communications in different globally famous journals, namely Lancet, Journal of American Medical Association, New England Medical Journal, ATMPH, and ICPJ, JCP, etc., etc., with more than 250 citations, which one is really outstanding. He is a supervisor of so many MD and DM students in Calcutta School of Tropical Medicine. He is an examiner of several PhD students. He already supervised a large number of researchers, but many of his students are working in different countries of the world with external reputation, which they have obtained from Professor Bhattacharya. I do not want to extend much more regarding introduction of Professor Pranab Bhattacharya because he himself is sufficient to be glorified the beauty, academic beauty of Calcutta School of Tropical Medicine. And people assembled here to listen Professor Bhattacharya followed by Professor Brahman Mukherjee. So I should not waste time much more. It's only a ritual to introduce the speaker. So I am directly requesting Professor Pranab Bhattacharya to deliver his talk. Professor Bhattacharya, please.
Am I audible?
Yes.
Yes. So shall I start? Okay. Now, in COVID-19, actually started in December 2019, just 1 month before the Chinese Spring Festival, where multiple cases of pneumonia of unknown etiology appeared in the Wuhan of Hubei province of China. Later, a novel coronavirus was detected in the pneumocytes of the lung tissues and also in the bronchoalveolar lavage samples. And analysis by the metagenomic next generation sequencing, it showed that these coronavirus are different in the genomic sequence of other human pathogenic coronaviruses. Previously, the coronaviruses also did epidemic conditions throughout the world. That was SARS, or which is already known to everyone, that it is the severe respiratory syndrome that causes like ARDS, and that was first detected, also came out in the China. And secondly, that was in 2012, another coronavirus outbreak occurred that we call MERS. That is, these are the two important coronavirus. Now, as per today, there are over 26.21 million cases of COVID-19 in the world. And the death occurred about 86 lakhs 80,068 deaths globally. And then recovered cases as per today is 18 lakhs 470,179 cases. And currently the death occurred 68 lakhs 12,582. About uh, no, sorry, mild conditioned are 68 lakhs 12,582, almost 99% are mild condition. Serious COVID condition is about 1.1%, that is 60,584, those who are still in the critical case. And daily new cases about 4 lakhs, and daily death is around 10,000 throughout the world. Now, India is actually in the third position of uh, number of infected cases, and that is about 3853406 infected cases. Daily new cases for the last week onwards, it is about 83,000 like that in the last week of the August, and 35 states of uh, Indian states and union territories are affected. Total involvement of coronavirus per 1 million population in India is about per 1 million is about 2,788 per 1 million, and total death per 1 million is 49, and there has been an 44% increase of total number of deaths from corona. It is 57,715 deaths to 67,376 deaths in a week. And the highest involvement of the Indian states are Maharashtra, followed by Tamil Nadu, followed by Andhra Pradesh, followed by Karnataka, UP, and West Bengal. In West Bengal, the confirmed cases till today is 1,68,697 cases, and active cases are 24,445, and already 3,339 deaths occurred from March 21 to today. And daily positive cases are coming 2,976, and average daily death in corona, it is 56 today, average daily death. So this coronavirus, uh, please previous slide, will you please send the previous slide? Yes, previous one. Yes. So actually, this coronavirus is actually identified into the pneumocyte of the lung, and this was identified in the sea market of the Wuhan for from 4 kilometers away from the BSL-4 laboratory of the virology laboratory of the Wuhan, and uh, so while research is going on whether that coronavirus transmission can occur from animal to the human host. Actually, coronavirus, the animal coronavirus are restricted within the animals, whereas human coronavirus restricted to the human. But the transmission from from animal to human is this time first observed, particularly on the sea market, the food from the sea market of the Wuhan. Now, January 30, 2020, WHO considered that the virus is an emergency international concern. And in March 11, 2020, WHO actually declared that it is an pandemic coronavirus. In February 11, International Committee of Taxonomy for the virus named this virus as a SARS-CoV-2 virus. And this is the seventh virus in the family of the coronavirus. In 2002, now SARS-CoV resulted in China and resulted much death. In 2012, March already found into the Saudi Arab and resulted 815 deaths. But you can find that this novel coronavirus has a huge transmission rate, and further and more death rate. Next slide, please. Now, why we call this corona? The coronavirus is a crown-like virus. It is an oval virus crown. You can find that this crown is like the solar coronas, and these are the club-shaped crown. And you can find that it has got certain proteins within the surface. This crown-shaped structure are called spikes. So the name of the protein is spike protein. And secondly, now there are another protein you can find that on outer surface of the coronavirus. These are the M protein, or this is a membrane called membrane protein. And there is another inner this membrane protein. There is an envelope protein, and within the virus itself there is a long single-stranded RNA is present, and that RNA is a single-stranded RNA, and within the close to the RNA, or almost attached to the RNA, there are nucleocapsid genes are also present. Next slide. Next slide, please. Now about the virus. Now the coronavirus can be divided into 5 branches. Now our corona branch 1 virus, actually these are the lentivirus group, and they belong to mitovirus, noronavirus, and oronavirus. Branch 2 group belongs to picoRNA virus, and within that group there is nidoviribis. Now the coronavirus, all coronavirus belong to this nidoviribis group. Branch 3 is alpha viruses and toriviruses or nodaviruses, and branch 4 is a cystovirus, reovirus, and titovirus. Now, according to the host targets, the coronavirus are again divided into the animal coronavirus that infect the animals like seafood, snakes, bat, pangolins, dogs, etc. And today's coronavirus is considered to be originated either from the bat or from the pangolins. Now, in the dog, these coronaviruses causes respiratory symptoms, and that is called canine respiratory diseases. And the pathogenic human coronavirus has got again 4 subgroups. These are alpha coronavirus, beta coronavirus, delta coronavirus, and gamma coronavirus. And each alpha coronavirus again are subdivided into 1A and 1B, and beta coronavirus is subdivided into 2A and 2D coronaviruses. Next slide, please. Next, okay. Previous slide. Previous one. So that coronavirus has got, so it belongs to the nidovirus group, and for this content, the positive stranded RNA, which are spherical, and the size of this RNA about 35 kilobase per unit, but and the maximum size RNA of this virus is the largest RNA virus, largest genome RNA virus, but the viral diameter is 50 to 200 nanometer. Now, this virus undergoes replication within the cell, and these are by the set of mRNAs. By development of the mRNAs, it will be proliferating in the template. Next. So it has got positive senses RNA, and size I have told. Now, usually that one. Okay, next slide, please. So these are the name of the 4 main subgroups of the coronaviruses, which are human coronaviruses, and there are 7 subgroups which can infect the coronaviruses to the people, and these are 229E alpha coronaviruses, NL63 alpha coronaviruses, OC43 beta coronaviruses, HKU1 beta coronaviruses. Now, these coronaviruses actually cause common cold-like symptoms or influenza-like symptoms. But the other coronaviruses, which are MERS coronaviruses, actually that is also a beta coronavirus group, and that results on Middle East respiratory syndrome, and that occurred into the Saudi Arabia and resulted more than 800 deaths. Now, SARS-CoV beta coronavirus causes severe acute respiratory syndrome in 2012, and that causes SARS-like syndrome. And today's coronavirus is 2019. It is a novel coronavirus. Next slide, please. So here you can find the different types of the coronaviruses, human coronaviruses. Actually, those are causing the uh, infection to the human groups. And here actually, I can find here, this is the SARS coronavirus group, and here is the uh, that is in coronavirus, but novel coronavirus group are here. Next slide, please. And okay. Now, generally, these SARS and MERS both, and also the 2019 novel coronavirus genome actually encodes three non-structural proteins, such as chymotrypsin, like proteases, papain-like proteases, helicase-like proteases, and other polymerase enzyme, that is RNA-dependent RNA polymerase. Remember, this RNA-dependent RNA polymerase is actually the polymerase specific for the novel coronavirus 2019. So, for detection, a confirmatory detection of the novel coronavirus, we require identification of that RNA-dependent RNA polymerase gene, or RDRP gene. We, by the RT-PCR technology, we actually identified two important genes to be called very specific for the positivity. One is RDRP gene, and that is RNA-dependent RNA polymerase, and other is ORF12 gene. Other proteins, or like genome protein factor released from the genome, are the spike protein, such as glycoprotein, then other NSP genes, or that is called non-structural protein genes. There are 6 non-structural protein genes present into the virus genome. Next slide. So you can find that what are the different, so many coronaviruses are there, so many. Now, the upper 4 are the SARS coronavirus sequencing genome. These are the red one, these are the beta coronavirus genome. Now, this coronavirus has got a specific sequencing than other SARS coronavirus in the RDRP genome particularly. Next slide, please. So these are the various coronaviruses that are involving the as per genomic sequence. Now this lower part, about 96% of this coronavirus genome has got sequencing similarity with the other bat coronavirus, or from bat coronavirus. So there was actually a kind of theory that is called the uh, biological war preparation by the China, that it is a new biological war that does not actually fit with the sequencing, that and it is actually derived from the bat coronavirus, or very closely from the pangolin coronavirus. So transmission from the zoonotic to human side occurred, and that is very important. Next slide. So these are the various history of the coronaviruses that occurred in the different time. Now, in 1937, this coronavirus was found into the chicken causing hepatitis, and which is transmissible, resulting gastroenteritis into the swine. In 1960, there was another swine coronaviruses. Then in 2002, actually 223 SARS coronavirus was found in the China. A total 8096 cases throughout the global, out of which 774 cases was fatal, and it included 29 countries, and of which the health personnel got involved is 21%. In 2012, MERS coronavirus, it involved also 227 countries, and 2,494 are affected. Death was 858%, cases 34%. But here, if you look at the death number, it is very less globally, 1.1%. So, but it is transmissible is very high for that virus. Next slide. So this is again here that different types of outbreaks occurs. So these are 2029E OC43 that occurred in 1960. It causes just common cold. Now in 2002, 2 to 3 that causes severe acute respiratory syndrome. Now HCOV in 2004 occurred bronchiolitis. In 2005 occurs, it is respiratory diseases causes. In 2012, MERS occurred. It is Middle East MERS syndrome, or and that occurred from the one from camel. Camel meats. MERS occurred in the Saudi Arabia from the camel meats. And in 2019, actually, the Wuhan coronavirus occurred. Next slide. Next slide, please. So that ACE protein. Now, previous slide, please. One slide. Previous slide. So I told that this coronavirus has got the several proteins. One is called nucleocapsid protein. This nucleocapsid protein actually binds up with the genomic or subgenomic RNA, which is involved in the process of the replication. I showed you. Secondly, M protein, these are the membrane protein, which are abundant on the viral surface of the COVID and responsible for the assembly of the all proteins to form a new virus. S protein, these are the spike protein. That is a very important protein. And this spike protein, it is a glycoprotein. And that result, response, it has got two parts. One is called S1 protein and another is S2 protein. And this S1 protein is going to the entry of the virus to the cell by the ACE2 receptor. So wherever there is ACE2 receptor, the virus will get attached. For the entry of the virus to the within the cell, it requires the another protein, which is called fusion protein. Now this fusion protein and S1 and S2, in between these junction, there is a fusion protein. Now, if the fusion protein, if it is remained in junction, that will not be active. But to make it active, we require the break of the S1 and S2 protein. And then the fusion protein gets active. And then it will get attached with the S protein and with the ACE2 receptor to form the tight bindings of the receptor. There is another protein which is called E protein, and this E protein also helps for the viral assembly and membrane permeability and host, and another protein which is hemagglutinin protein. This hemagglutinin protein is required for the viral entry and for the viral replication. The next slide. So I have already told, so this is responsible for the attachment of this spike with the ACE2 receptor wherever these are present. Now, where these ACE2 receptors are present, These ACE2 receptors are present in all respiratory epithelial tissues, like pneumocytes 2 of the alveolus, in endothelial cells, in the nerve cell, both in the peripheral nervous system nerve cells, where neuronal cells are involved, in the central nerve cells system, where glial cells are involved, in the liver, hepatocyte, in the GI mucosal cells, and also in the renal glomerular cells. So yes, this S protein, both S1 and S2, these are composed of three identical chain of messenger RNA M1273. Now S protein is responsible, I told that it is for recognition of the ACE2 receptor and attachment for actually when S2 is responsible for the release of the fusion protein after cleavage on the host by the host proteases. Now, for the cleavage of S1 and S2, the trypsin and furin molecule are required. Now, this acts at the binding site of the S1 and S2. And so long this binding does not cleaved by the trypsin and furin, this fusion protein cannot be activated. Next slide. So I told you actually this is where from this virus is coming out. So SARS-CoV-2, the origin is from the bat. I showed you. Mostly MERS is also from the bat and also from the camel. These are the origin uh, of the virus. So SARS is bat or pangolins. Next slide. So how the transmission occurs? Now, the transmission occurs by the droplet, that is by the touching of the touch phenomena occurs, direct touch. And also, there are concern that this virus is spread also by the aerosols in the closed spaces, in the ward, particularly in the hospital, then in the OT, and then in the chamber. So, and if you speak on very loudly while singing like that, and that can travel the virus within the 6 feet. Now, so this already I've spoken. Please, Asha, please next slide, please. So, how does the virus get entry into the cell? That is a pathogenesis. So the spike protein undergoes proteolytic cleavage by the trypsin and furin enzyme in the S1 and S2 binding site. After that, they will release the fusin peptide, and that cause activation of the membrane fusion mechanism with the S1 receptors and the S1 protein. Now, S1 protein must recognize and has to get attached with the ACE2 receptor, and that is done by the fusion peptide. After that, there will be, please, other side, previous slide. Right. So after that, it will enter into the cell. And before entering of the cell, now there requires the certain conformational changes of the S1 glycoproteins. Now, with the conformational changes, they enter into the cell to form in the form of the endocytosis. Now, endocytosis occurs within the endocytosis. There is a liberation of the cathepsin L, and this cathepsin L is liberated only and when the pH of the endocytosis are acid in nature. And here is actually the prophylactic use of the hydroxychloroquine can act. The hydroxychloroquine actually alters the cathepsin L liberation and can make you prophylactically non-viable for the viral infection. And if at all viral infection occurs, the symptoms will be very less. After that, the further activation of the membrane fusion occurs within the endosomes. Now, next within the endosome open up and they ultimately release the virus within the cytoplasm, and with the proteolysis enzyme, it will cause uncoating of the viral nucleocapsid. Next slide. Next slide. And that nucleocapsid is dissolved and the single-stranded RNA are released within the cytoplasm. Then actually the replication starts. Now replication starts by a very complex method that is called RTX method or RTX complex. This RTX complex initiates actually the first signal for the transcription of transcription, and uh, that occurs, that cause stimulation of the reverse transcriptase enzyme based on RNA dependent RNase enzyme. So these RDRP gene are specific for each specific subtypes of the coronavirus. So this is a gene which I have to test to tell a person whether it is positive or not. That can be done by the RT-PCR or by the gene expert or by the TrueNAT, whatever it may be, and also by the antigen test. Now, this RT complex, RTX complex ultimately cause a double membrane structure within the cytoplasm, and the RNA genome actually form within the open reading frame, ORF genome we call. This ORF genome is then formed, and this ORF, within the ORF genome, there are two types, two ORF genome are present, 1B and 1A. And this 1A and 1B genome are present with the beta coronavirus group. So that is not a very specific one, but whether coronavirus infection occurred or not, that I can detect by the ORF gene group. Now here actually the replication of the coronavirus occurs. So that can be another diagnostic gene for the COVID-19. Next slide. So what is the function of this ORF gene? ORF, it is acting as a template to generate a full-length negative sense RNA. Then ultimately the positive sense RNA genome is prepared, followed by the various structural proteins are prepared. These are membrane, then spike, then non-structural proteins. These are all synthesized within the endoplasmic reticulum and within the Golgi apparatus. And all this protein goes there, and ultimately the viral assembly occurs and new viral is formed. Now this ultimately are transported towards the new cell to the cell membrane, infected cell membrane, through a smooth wall vesicles, and these are released by the exocytosis mechanism. Next slide. Next slide, please. Now, now this, how does the CD8 cells are coming? Now, these viruses are present within the pneumocytes, and the macrophage, previous slide, please, previous slide. Previous slide, please. Now, this ultimately, these viruses are taken up by the macrophage system. And how this macrophage system are taking these viruses? Now, we know that every kind of bacteria, virus, whatever it may be, now these are required the antigen presenting cell, or these are the dendritic cells. Now these dendritic cells are the actual main component of the respiratory immunity for in the alveolus. Now as soon as the virus get entry within the body. Now, within 40 minutes time, this the virus get attached to the ACE2 receptor and gets entered into the cell, and replication occurs to the many virons. Now, after that, these dendritic cells, they reside within the dendritic cells. Now, this dendritic cell will cause stimulation or will present this virus or bacteria, whatever, to the either T cells or to the B cells. Now, here the T cells are responsible. Now, these cells, these T cells can be again two types of cells. One is called CD8 cells, one is which are the cytotoxic cells, and other is CD4 cells, which are the helper cells. Now, why the virus are getting attached to the dendritic cells and to the alveolar macrophages? Now, these are because of the presence of certain intracellular adhesion molecules, and these adhesion molecules are called dendritic cell signal adhesion molecules or L signal adhesion molecules. Beside this SCE2 receptor, the macrophage contains all these adhesion molecules. So this macrophage, wherever this dendrite that cell contain this molecule, they will engulf these apoptotic cells and the apoptotic pneumocytes, particularly which contain the virus, lip virus. So the macrophage will ultimately take up the pneumocyte that contains the lip virus, and that is how the macrophages are virus goes within the macrophages. Next slide, please. So this macrophage containing virons will ultimately move to the draining lymph nodes to present this viral antigen to the T cell. So I told that there has got two type of CD4 and CD8 T cells. Now CD4 cells are actually trying to activate the B cells. And please, previous slide, previous slide, previous slide, please, previous slide, previous slide, previous slide, back, 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 back. Yeah, well, next slide, next slide. Yes, this one. So this will cause CD4 cell will activate B cells, and these B cells are cells for production of the antibodies. So if the B cells are stimulated by the CD4 cell, we can expect that immunoglobulin against the spike protein will be produced, and these are the IgG antibody or IgM antibody. Now IgM is the first antibody which are produced, followed by after long period time the IgG antibody. The IgG antibody is a neutralizing antibody. So a person who has been already infected by the virus will ultimately develop IgG antibody, and if you put the IgG antibody into an infected person, so he will be cured. Now, CD8 cells are viral spike protein specific CD8 cell is required, and that CD8 cell will try to kill the virus. And whenever the virus kills these macrophages containing this CD8 cell, kill the macrophages containing the virus, they will release the cytokines. Next slide, please. Next slide. Next slide. So, no, that slide, please. Back slide. Yes, yes. So, patient with the moderate or severe pneumonia actually shows reduced number of the lymphocyte T cell. Now, this is a if you count the number of lymphocyte T cells or total lymphocyte, you can have a good assessment, particularly whether the patient is progressing from the towards the severe pneumonia or not. Now, moderate to severe pneumonia or not. Actually, less than 3,000 lymphocyte count is very indicative that the patient is going towards the bad prognosis. Secondly, the release, macrophages release interleukin 6. The normal value of interleukin 6 is 6 nanogram per milliliter of the blood. Now, when the patient has got the moderate group of the pneumonia, it goes rise. And if it is above 6 times of the normal value, that is 36, more than 36 or like, it can go up to 100 like that. That is called cytokine storm. And that is a very dangerous cytokine storm. And other cytokines are released interleukin 8, interleukin 10 is for fever, GM-CSF, very chemotactin proteins, and TNF. Now, this TNF causes necrosis, and sometimes the follicles are get necrosed. So, sufficient B cells are not produced for the TNF production. GSF is another cytokine that further augments CD8 response and more T cells. Interleukin 8, actually they attract chemotactin for the neutrophils, and thus neutrophil accumulation are seen in the interstitial spaces and intercellular spaces of the lung, and, and this neutrophil acts as a double-edged sword, and they ultimately cause damage of the alveolar tissues. Next slide. Next slide. So neutrophil itself will cause damage to the alveolar tissue, although neutrophils are seen in the interstitial spaces. So the modern therapy for the COVID-19 to moderate and severe type of pneumonia, we have to stop the CD8 T cell responses. So dexamethasone is the treatment of choice from the day 5 onwards at the dose of 8 milligram per kilogram body weight recommended. But one should be very careful that dexamethasone can cause rise of the blood pressure too. So that may problem cause. So every day BP checkup is required. Now another drug we have known, that tocilizumab. Now tocilizumab is a monoclonal antibody against IL-6. Now it can reduce released IL-6, which has been released from the IL-6 storm. So one injection of tocilizumab, if the patient have got this high interleukin 6, will be beneficial to further attack. Only one injection is required, not more than one, because tocilizumab itself is an immunosuppressive drug, and that can result a kind of super infection with the bacteria, and patient will die of sepsis. Many times patient dies of the sepsis due to this steroid and tocilizumab. Next slide, please. So basically, so many deaths that we are seeing for the patient are for the cytokine storms. And these cytokine storms not only causes lung damage, fibrosis, and etc., but it will cause also multiple organ failure. So it is done. If it has to be done, and normal value is 6 nanogram per dl of blood. It causes damage to alveolar structure, myocardial damage, vascular endothelial cell damage. So sudden rise of cytokine storm can develop in apparently normal patient. The physician came and saw the patient that he is quite okay and normal, but his cytokine is IL-6 is high. But suddenly within 1 hour or 2 hours, the patient goes dead. That is because of this cytokine storm. And that cytokine storm has to be done from 5th to 12th days onwards. Now, this can be treated by either steroid or by the tocilizumab. However, tocilizumab is very expensive drug, about cost 40,000 each injection, and in the black market it is not available very easily. So in the black market it is 1 lakh. So immunosuppression is very high with the tocilizumab. Be careful. So no second injection of tocilizumab. Next slide. So another important cause of the death in the COVID-19 patient is actually DIC, disseminated intravascular coagulation, or thrombosis, or coagulopathy. As I have told, that ACE2 receptors, these are present in many cells. One of important cell is endothelial cells, and these endothelial cells has got much overexpression of the ACE2 receptor. So, and this and the virus can proliferate within this ACE2 receptor, and they cause damage of the endothelial cells, and that result clot formation and thrombosis. So thromboembolisms and thrombosis is a major cause of the death, particularly patients who have developed pulmonary embolism. Certain cause of death is a cause of pulmonary embolism or acute myocardial infarction. These are due to the thrombosis part. Now, pulmonary embolism is seen in the postmortem studies of the COVID-19 dead body, both in Italy and UK and in China. Next slide. Now, whether the patient has trained for developing thrombosis or not, you can identify by a coagulation profile study. So what coagulation profile study you have to do in for every patient? One is prothrombin time. Now, a second is fibrinogen. Third is INR. This has to be monitored. INR means international ratio of the clotting time and thrombin time. And that has to be monitored always after day 5. Raise of fibrinogen degradation product. And one of such fibrinogen degradation product is D-dimer. Now, D-dimer value is normal is 1 nanogram. Now, if it is more than 1 nanogram, then it is a hypercoagulable state. And this can lead to sudden death from the acute pulmonary embolism or acute myocardial infarction and CPA or brain stroke. So, it is always advisable that the patient who has got admitted in the day 5 onwards, you have to put the patient under low molecular weight heparin to give an all patient. It is a protocol of today's treatment. Now, always try to monitor the patient with the prothrombin time and INR, because low molecular weight heparin may cause intracranial or subdural hemorrhage or internal hemorrhage. Even one of my friend are now admitted in a medical college, Kolkata, who has got the COVID-19 infection, has developed this intracranial hemorrhage because the low molecular INR was not maintained very well studied. So whether the patient tends to develop thrombosis, it can be replaced as well. So monitor the patient with the INR daily. Next slide, please. Now, what is a pathology? That is a vibe part. So so far, as it is a very infectious virus. Now can be present in the body fluid, can be spreading from the body fluid, saliva, any body fluid, pleural fluid, ascitic fluid, abdominal fluid, synovial fluid, everywhere this fluid is there. So a very limited autopsy study has been done. Now, that is a post-mortem after the death we call autopsy. Now, first autopsy study was published in the Journal of Clinical Pathology by the British group. Now, this histopathology of the lungs in that study showed edema. That number 2, the type 2 pneumocyte hyperplasia. Remember that here pneumocyte is not dead. And this pneumocyte has got viral inclusion body. And if you look at the pneumocytes in the electron microscope, you can find the presence of this viral inclusion body in these cytoplasmic vesicles or in that part. Now, infected cells, so there is no death, but intact synthetic activity and loss of cilia is present in the pneumocyte. And diffuse alveolar damage is there. Now, you can find there the airspace edema, type 2 pneumocyte hyperplasia, squamous metaplasia, multinucleated giant cells, and acute bronchopneumonia. And it affects both the alveolar epithelium and alveolar macrophage, resulting diffuse alveolar damage. Next slide. Next slide, please. The important part of this, no, previous slide, please. Previous slide, previous slide. Yes. The next, no, no, no. Next slide. Next slide. Yes, that slide, please. The next important thing is that pulmonary artery. Now, this pulmonary artery shows hyaline necrosis with thrombus formation and capillary punctuation. Now, if it is only ARDS, so we would get the alveolar hyaline membrane. That is a very important thing, which is a diagnostic finding of ARDS. But this COVID-19 showed inconsistent hyaline membrane. Some group shows the presence of the hyaline membrane, some group could not find the hyaline membrane. Interstitial infiltration with the inflammatory cells and neutrophil and macrophages. Now, alveolar lumen contain lymphocyte CD8 plus cells, macrophages with the extensive damage. But from myocardial tissue, if you look at the heart tissue, you will find that myocardial tissue appears darkened cytoplasm and there is hypertrophy, which suggests actually the patient had certain ischemic heart disease or has got left ventricular hypertrophy or hypertension. So the patient who has got blood pressure, so the patient who has got ischemic heart disease, so the patient who has got hypertension, so the patient who has got diabetic mellitus, they are very much vulnerable patients for going from moderate to severe pneumonia in case of the COVID-19. And these are the risk factors for the COVID-19. Next is the platelet plaque thrombosis seen in the coronary artery. So, particularly those who have got ischemic heart disease or type 2 diabetes mellitus. So you can see that these are not very specific picture of the ARDS. It's a mixed picture, both the ARDS and also there is feature of the thrombotic manifestation within the pathology. Next slide. Next slide. Now, question is how to diagnose that. Now, a patient that is we have to diagnose this patient by those who are today most of the patients are asymptomatic. So a patient having fever, only fever, or fever with the other symptoms, mild symptoms like cough, sore throat, etc., or dyspnea, there is difficulty in the breathing, like that. So this patient, if comes, then we have to go for the test, and the test is very important for the isolation of the patient. Now, the sample is a oropharyngeal swab is taken. Now, this oropharyngeal swab are subjected to either RT-PCR techniques or subjected to RT-PCR or by the gene export or by the TrueNAT. Uh, these are actually the RT-PCR technology is an open system technology where you have to first feed the material with the RNAs and then you have to put into the PCR technology and to find out the RDRP gene or ORF1 or B gene. The TrueNAT technology and RT-PCR has got 70% to 80% sensitivity. It may be false positive, it may be false negative. If you have got the dead viron, it will give the false positivity. If you have a very low percentage of that, it will got negativity. Now, CT value is one important thing in the RT-PCR. We must say that is the cycle value, cycle time value. Now, if it is above 35 to 40, it is inconclusive. Above 40 is negative, and below 35, it is positive. Always consider it is a positive value. And this depends on the viral load of the patient. So fever, always a fever. So if you have got the positivity of this patient, then you have to notify the health authority. And secondly, you have to decide the patient for isolation or for the admission. Now today the home isolation is given to the milder symptoms and moderate who require the oxygen, and with the risk factor they are admitted. It is a protocol today. Next slide. Now the question is artificial. Now question is that today, if I have got infection, and even after 14 days or 15 days, even 28 days, it is showing positivity. That is not due to the infective virons. It is possibly for the dead virons. So the gold standard is always culture in the biosafety lab. 4 types of biosafety lab, and at a bronchoepithelial cell culture or human embryo kidney cell culture or varroa cell culture is taken. Molecular testing, I told that these are the RT-PCR techniques. Now, then CBNAT is a one technology, just cartridge-based test, PCR. And third is a TrueNAT. Fourth is a gene export technology. These are various technology. And lastly, the sequencing, genome sequencing you can do. Question is serological technique. Antibody testing can be done whether IgG or IgG has been developed or not. If IgG is developed, in that cases, a patient can be less infective, but the IgG does not remain for a long time because the follicles is not very well developed in case of the COVID-19 virus. And moreover, the T cell that are directed for the virus containing cell that also can destroy the germinal cell follicles of the lymph nodes. So B cell response may not be very good. So weak IgG may develop. So this is important, however, for the serosurveillance technology. And another is antigen. Antigen that is not from the blood, but that is from the throat swab or oropharyngeal swab. You can do the rapid test, antigen test by 30 minutes time. Next slide, please. So I have done, I told it there is antigen virus test, that is by ELISA test or immunofluorescence test. Next slide. So I was talking about that. This is the follicle. That is a follicle where the germinal center is proliferated. And now this within the this is the cortex, T cells region of the cells. And next slide. And these are actually this in the cell culture. You can find that epithelial cell culture. You can find it. Next slide. Next slide. So you can see the virus, the arrow path, and this is the electron microscopy of the virus showing the spikes, the genome part. Next slide. So strategy for control. Now, early recognition must be done. So first is encourage all health workers to high level of clinical suspicion. Unless you suspect that I suspect my colleagues or I will not get myself protected. Now institutional screening and then quarantines is important. Awareness to the publics, promotion of the respiratory hygiene is an important preventive measure, and suspected cases should be placed in the isolation, home isolation, or isolation like that. Next slide, please. Next slide, please. Next slide. Uh, So respiratory hygiene measures, hand hygiene measures. Always wash your hand with the soap water or with the 70% alcohol, because the viral membrane itself is a lipid membrane. So with the alcohol, 70% alcohol, if you do with the water mixed alcohol, the membrane ruptures. So three-layer medical marks or surgical marks to all suspected patient in the OPD and indoor. You must cover the nose and mouth during the coughing and speaking, or when you cough in the elbow. Perform hand hygiene after contact with the respiratory secretion by soap and 70% alcohol. Use always protective equipment with the face shield and goggles. This is for the doctors. Prevention of needle sticks or sharp injury where there is a possible of aerosol generation. Safer waste management, particularly of masks, PPE kits, or like that. Environmental cleaning and sterilization of the patient care equipment, and also linen through cleaning with the water and detergent. And next is all of hospital wards and floor, table, and etc. that has to be disinfected by the sodium hypochlorite solution. Next slide. So you have the following signs and symptoms. Fever, any fever today, of course, today is a time for the malaria, today is a time for the dengue, but any fever, you have to suspect the presence of COVID-19 patient. So fever clinic are developed in the healthcare system. Once patient has got the fever of 102 to 100 to 103 degree Fahrenheit, on the day 3 or day 4, you have to go to the fever clinic where they will take the blood, they will take the swab and etc. Second is a coughing. Coughing is a dry coughing, is a very important. And second is your sputum production is about 28%. Pneumonia. Pneumonia, it is the X-ray finding is not very well and good X-ray finding, but it is the CT finding which shows 90% positivity. That is HRCT finding 90% positivity. Now, there are various 16 strains of COVID virus. Now, some of the strains of the COVID virus has got atypical symptoms. That is, I told that GI mucosa has got ACE2 receptor in high concentration, like the endothelial cells, and this causes vomiting, diarrhea. So that some presentation will be with the vomiting and diarrhea presentation will be there, and huge water loss and dehydration will be there. And secondly, renal involvement. Kidney involvement, particularly those who have got the chronic kidney disease, CKD, diabetic patient, or those who have got the dialysis patient, they are more susceptible for much more renal parenchymal injury as well as tubular injury and acute renal failure. Next slide, please. So severe symptoms are like these are the symptoms: fever. Generally, after 2 to 7 days, they develop cough, mild or breathing difficulties. Now, dyspnea occurs usually for the moderate to severe group. Sometimes one thinks that happy hypoxia can occur. Now, happy hypoxia, it's hypoxia or breathing difficulty, not in rest. But if you walk the patient for more than 6 minutes, the patient SpO2, that is oxygen concentration, will fall down below 94. And second is gastrointestinal issues, and third is general body aches. So next slide, please. So signs and symptoms of COVID-19. COVID-19 patients, so we can divide the COVID-19 patient today asymptomatic, Patient, they have no symptoms, but they have got RT-PCR or antigen positivity are present. They are today maximum number, and they are actually the potential source of getting infected. Second is mild symptoms. These are the very flu-like symptoms, and they can be managed easily in the home isolation with the drug erythromycin, zinc, vitamin C, vitamin D, and next continuous monitoring. Can if the patient home is not sufficiently good for isolation, he can possibly go to the safe home by the government or by the private hospital. Happy hypoxia, I have told it, if the patient has got oxygen saturation below 95%, 94%, and on walking for more than 6 minutes, then hypoxia condition can develop. And if the patient has got happy hypoxia, but the patient has got comorbid condition like hypertension, diabetes mellitus, like COPD, like chronic obstructive pulmonary disease, like asthma, like that. So that must be admitted. Moderate symptoms with fever and HRCT uh, changes in the lungs, parenchymal oxygen saturation drop must be allowed to be issued. Hello? Okay. And incubation period is 4 to 5 days. Next slide, please. Next slide, please. Next slide, please. Yes. No. Previous slide, please. Previous slide. So, fever above 37 degrees centigrade, about 83 to 98% on admission. Every fever today has to be tested for COVID-19 by RT-PCR gene. Dry cough, 76 to 82%. Photon production, 28%. One very important thing one must know, if you have got anosmia, that is the loss of smell or alteration of the smell, it is you must have COVID. This is 99%. Loss of taste, it is 70%. Myalgia, 44 to 50%. Dyspnea, 55%. Lower oxygen saturation below 95%. Headache found in 10 to 20%. Atypical presentation may be present with the diarrhea. Next slide, please. So what test you have to do on the time of admission? Now, one should do total hematocrit, including neutrophil lymphocyte ratio. Lymphocytopenia below 300 is a sign of worsening of the disease progression in 70% cases. Liver function test, if you have high SGPT, SGOT, this causes hepatitis. Prothrombin time, high prothrombin time, INR indicate liver involvement. Low molecular therapy, weight therapy, when given, you have to do that INR and PT. PT must not be done above 12 seconds. INR must not be above 12.3 to 13.7 seconds. LDH, and if it is shown 260 international unit indicate progress in inflammation, where IL-6 cannot be done. Where you don't have IL-6 facility, you can do LDH. CRP, procalcitonin level, you can do for development in selected cases. RFT, that is urea creatinine, you have to do. HRCT of the lung. What is found is a ground glass opacity in the bilateral or unilateral. And remember that ground glass opacity is a very diagnostic criteria for the COVID-19 patient. Next slide. So that is interleukin 6. I have told it is on the day 7 to 8 day on admission you have to do. It is normal value 6 nanogram per DL. It goes 6 times, indicate progress towards severe disease and ARDS. You must give steroid and dexamethasone at the rate of 8 milligram per kilogram body weight. IL-6 has to be repeated every 72 hours. If tocilizumab is given, consider only one injection, not more than one injection, not second dose. It will lead to the sepsis. D-dimer value, if it is 1 microgram per DL, that is chance of thromboembolism, thrombosis. You have to stop low molecular weight heparin. And be careful when low molecular weight heparin, whether intracranial hemorrhage or brainstem hemorrhage, etc. does not occur by looking at the INR. Care for whether the patient is undergoing stroke or acute myocardial infarction or developing cardiac arrhythmia. Do troponin T test if the patient complains of chest pain. At everyday oxygen saturation management. So patient, actually we have mild, 78% of the patients are today mild cases and they recover. Few cases are moderate cases and severe cases are 5% cases. Death occurs in 2 to 3% cases globally. And maximum death occurred in the age range of 55 to 85 years old. In India, 329 doctors has been already dead from the COVID-19 cases. And previous slide. So 329 cases doctors has been died, of which now Kolkata 21 deaths of the doctors happened. Majority of the death occurred are from the severe pneumonia cases. Dyspnea is a very common symptom with accompanying hypoxia. Respiratory failure occurs just after the onset of dyspnea and hypoxemia. And severe COVID-19 meets the criteria of the ARDS, which is defined as sudden acute onset, bilateral infiltration, tachypneumonia. I think that hello, sir. Hello, yes. তাড়াতাড়ি ঠিক আছে, ওকে করে নিচ্ছি। So next slide. So why the doctors actually died? There are many causes. So actually the doctors has got maximum number of the viral load, doctors and nurses. So those who are above age 55, then the patient, majority of the doctors are died. Actually 14% of the death of the doctor throughout the India are pathologists and microbiologists while doing processing of the tissue for cytopathology or FNSC or from the testing laboratory. Thank you. Thank you.
Hello, Chandan sir. Hello.
Chandan, please take over. Chandan, please take over. Professor Brahman Mukherjee is awaiting.
Sir, I think there is some technical issue from Chandan sir.
So should I
Please continue.
should I start?
Sure, sir.
Professor Mukherjee, are you there? Professor
Hello?
Mukherjee, are you there?
Yes, I'm here. Thank
Okay.
you, Dr. Roy.
Okay. So my role is to introduce you to the audience this time. Let me start my job. Minimum time. Professor John D. Kalfleisch, Collegiate Professor and Chair of Biostatistics of the University of Michigan, Professor Brahman Mukherjee, who was a brilliant student of statistics in Presidency College and ISI Kolkata during 1990s, hails from a family of art, theater, music, and culture. After having a degree in India, she won a scholarship from Ramakrishna Mission to study in USA, where she enrolled in master's and doctoral program at Purdue University. Being inspired by teaching of Professor Mousumi Ghosh of ISI Kolkata, Professor Brahman Mukherjee chose designs of experiment to initiate the topic of a doctoral thesis in Purdue University. After her PhD, after her PhD, Professor Mukherjee joined the University of Florida as an assistant professor, and there she came in contact with Professor Malay Ghosh, the world famous Bengali statistician known for his path-breaking work on Bayesian statistics. Association with Professor Malay Ghosh came as a golden turn in the career of Professor Brahman Mukherjee, And under his influence, Professor Brahman Mukherjee turned into a Bayesian statistician and gradually entered into the world of biostatistics and data science. In the meantime, in 2005, she has joined the biostatistics department of the University of Michigan and started working there with schools of medicine and school of public health. There she got the opportunity of working with clinical doctors all over the world and started translating complex medical and social problems into mathematical language. Till then, she is in the University of Michigan, and now the John D. Kalfleisch Professor of Biostatistics. Professor Mukherjee holds a dual appointment in global health and epidemiology and is chair-elect for the Committee of Presidents of Statistical Societies. The point to be specially mentioned here is that Brahman Mukherjee is the first woman to head the University of Michigan Biostatistics Department. What Professor Brahman Mukherjee of today is known to everybody. All facts about her achievements are available in public domain, and if I start narrating them, the entire time of the program will be consumed. The fact is that she is now a world-famous data scientist with publications in all the top-grade journals of the world. I tried to tell some untold story about her. In this context, I should mention that besides being a prolific researcher of statistics, Professor Mukherjee has a real passion for Bengali literature, and her high standard of writing in Bengali is sufficient to impress anybody. Father of Professor Brahman Mukherjee is a great personality of Indian theatre. Yes, I am talking about the great Ashok Mukhopadhyay of theatre workshop. Professor Ashok Mukhopadhyay taught in the English department of Barasat Government College in early 70s. I heard about his magical delivery in the lecture theatre of this college while teaching Lady of Shalott by Alfred Tennyson. I requested some of the former students of Professor Ashok Mukhopadhyay through our alumni association to join in today's program. I don't know whether they have got entry into the program or not. So Brahman Mukherjee has a deep-rooted connection with this college and hence could not refuse the invitation of the principal in spite of his extremely busy schedule. Thank you, Professor Mukherjee. The audience is now waiting for a magical presentation from your end. So please pull up and start delivering your lecture. Over to Professor Mukherjee.
Thank you so much, Professor Roy. And this is very humbling, and it's a lot of pressure because no one can actually beat my father in terms of his articulation and magical presence in a classroom. But also I must refer back to my days in Presidency College, where Professor Roy used to teach us linear algebra, and I was never a very strong student. I did not study much, and I'm sure that many times I have caused a lot of disappointment in the classroom, but tried to work hard throughout my career, and I am looking forward to sharing a special narrative, a special part of my journey as an academic statistician into the world of COVID. So this is really a story, and it is not my work. I'm just presenting today on behalf of my team. It takes a village to raise a child, and it takes a whole army of people in order to produce research at a wartime pace and speed. So I'd have to thank all my colleagues. Most of them are from University of Michigan, but Parikshit Ghosh from Delhi School of Economics, and then Debashri from Johns Hopkins University. And you'll see some other people who joined this team, which we call the COVID-19 study group. And we started this project exactly, I remember the date, March 16, 2020. That was the first day of stay-at-home order at Michigan. And we are all perplexed. This is an unprecedented time, a crisis. And standing in March, I never really thought that we'll still be at home in August and talking about this research. So it is really an incredible pleasure, fortune to be able to talk to you all from my kitchen counter in Michigan to going to Kolkata, a city that I truly, truly love. And so before I begin, Dr. Bhattacharya gave a wonderful introduction to the pathogenesis and of COVID, and particularly his last slide, that how many human lives are lost, particularly healthcare professionals. So I want to start by paying my tribute and sincere gratitude to healthcare professionals and frontline healthcare workers who are saving lives and giving lives across the world. So thanks to those people, remarkable people. So today's narrative, I broke it down. Rather than giving very detailed account of the mathematical modeling that we did, I want to tell a story, the story of the last 6 months, personally, as a person, as a human being, as an academic, and being caught between with my hyphenated identity between two countries, United States and India, where the crisis has been particularly severe. So India will soon claim the second place, and US has been leading the chart for a long time. So it feels frustrating, it's tiring, and why with so much human capital and resources, we are not being able to defy this virus. So that's a story of a personal journey too. So I'd like to talk a little bit about pre-lockdown forecasting when we started this work, because that's really, really exciting to see that an academic work, a modeling work could make so much impact. And then I want to talk about the post-lockdown analysis. Lockdown seems ancient now as a concept because we have been in the unlock phase for quite a while. And then I want to talk about why it was so critical for our models to be updated every day and how the daily data was changing on the ground. And then in the end, I want to talk about something that we have done, which is connecting the epidemiologic models with the seroprevalence surveys that are being done in hotspots as well as in other parts in India. And I want to conclude from numerical vision and the details of science to a leap into the arts. So, so this was March and April, and this is a trilogy of our articles in Medium, pre-lockdown, during lockdown, and post-lockdown. And the contribution that I'm most proud of through this whole process is actually this app. Not the papers, not the media attention, but this app where everybody goes in my team every day, where our models for India and all its states are run overnight using a Bayesian algorithm, and covid19.org. And it has become a go-to place for many journalists, many epidemiologists, and I'm incredibly proud of the open source data transparency and our commitment to reproducible science and scientific rigor. So the paper, if you wanted to read a paper, our first paper is now published in the Harvard Data Science Review. And this is an incredible issue of the Harvard Data Science Review, which has many phenomenal data science works in COVID-19 all across the world archived into this single issue. So if you get a chance, and I'm going to share my slides, every article is linked from my slides, so you can directly go to the article and read more about other people's work on the pandemic as well. So when we started this work, it was March 16th, as I mentioned, and 72 hours, we worked together across continent, across the ocean, to come up with our models for predicting the future. The stochastic crystal ball has a limited radii, so we could see only this much, and what we are seeing today was beyond the imagination of the models, I must confess, at the very onset. And at that time, India had about 536 cases and 11 deaths. Standing here where we are having 80,000 cases every day and about 1,000 deaths, this seems like history. But that's where we stood in March. And we wanted to, we knew that, in India has a youthful population compared to Italy or United States. So we could not anticipate what the fatality rates are in India are going to be. But in spite of having a young population, there are several other concerns in terms of the comorbidities which have been associated with COVID-19, particularly with severe outcomes, as well as the fragile healthcare system, a large number of uninsured people, only 0.7 hospital beds per 1,000 people. So we wanted to do some projections about India because COVID is a disease which creeps in silently and then explodes. And we had seen that in many countries all across the world. So the world is experiencing a series of natural experiments, and we were maybe 2 weeks or 3 weeks ahead in the US to actually reflect upon India. And this was our first Medium article and our first projection, which drew a lot of attention, where you see in this curve that we projected India, and we're standing here, that March 16th, and the forecasts are going onwards. And we predicted that by May, which seems like, again, our projections have been really turned over by many things that are going on the ground, and I'm going to speak about that how to really reconcile what is going on the ground with the mathematical models on a daily basis. But what we had predicted, that the situation could be much serious as you move into May, and we predicted about 60,000 cases with an upper confidence interval of about 900,000 cases. And so and then we showed that their similar trajectories have been seen in Italy and US, where initially the number of cases were very small, and then there was this exponential growth. We as human beings, and particularly data scientists and modelers, are very used to linear growth of life, but exponential is something bewildering for all of us. So that work, and we went and we published this article in Medium, which is a non-traditional outlet for scientific work, but we could not wait. So we released that article and a 30-page report, and we never imagined that the media will pick it up. And so there was a lot of coverage in terms of our work, and criticisms, and worries, and some doubts, and some causes of concern. But this was probably the first robust technical report with a solid model at that time, at March 16th. So it was just the timing which made our work really being picked up by the media. And then on, as you all know, March 20th, we published this article, and there was a lot of discussion already ongoing across the world, and India had already closed its borders. On Tuesday, March 24th, came the decision of the national lockdown. And we can argue about non-pharmaceutical intervention strategies that have been rolled out in India, the timing of them, and the necessity of them, and the impact that it had overall on human life and the economics part of it. But I'm not an economist, so I'm going to only talk about the public health aspect of it. So the goal of a lockdown was really to capture a static snapshot of the population and buy time to prepare your healthcare infrastructure, a strategy for testing, contact tracing, and really bolster your public health information system. But with that started the movement of the migrant workers that we all have read about. And then also the cultural coalition coming together, that galvanization of people. We saw that, lots of rituals started, and trying to bring the country together. So, so when we talk about a pandemic or the public health intervention, we really have to assess it in a more holistic way as a society. And again, the limitation of this talk is going to be, I'm only going to focus on the models and the numbers more. And so since then, our work has really had remarkable international media coverage, and reaching about 2.6 billion. And Professor Roy mentioned that I have written many papers, but I'd have to say none of my scientific work, nobody really, all the papers that I've written together does not compare to the impact that public health and modeling and data science in general has had during this time. So obviously, where people are arguing and questioning and debating about the lockdown, was a lockdown needed? Did you get hurt in both the economic front and the public health front? But the lockdown was never really supposed to get rid of the virus. So the lockdown was to really ramp up testing, disease surveillance, contact network tracing, and prepare, as I mentioned. And also think about strategies of how we can optimally deploy resources based on what we are seeing and what are the upcoming hotspots. And then the ideal lockdown should look like that you have clamped down the virus to a level that it cannot soar back up again through the roof. So that's called a level of containment. And then you try to revive the economy. But I think that it's not the lockdowns which are killing the economy. As long as the virus is present and you cannot control it, human behavior will change, and economic enterprises and strategies and interventions are not going to be fully successful unless we can actually get rid of the virus and find a national cohesive strategy to control the virus. And so during the lockdown, of course, it was important to keep the essential supply chain going and support the most vulnerable, and also increase testing in frontline health workers and essential workers. But we do want to iterate that this is a long haul, and even at that point, the scientists kept saying that this is not supposed to be a piecemeal policy. It is not a patchwork pandemic with piecemeal policy. You need a long-term strategy in order to defeat this virus. Human beings are not defenseless or powerless against this virus, and there we have seen successes in many places. So as one of my friends said, that before the lockdown, we all knew that this tsunami is coming, the number of coronavirus cases is coming. At that point, we had a picket fence, and we need to really know more. We need to know more science about the property of the virus that Professor Bhattacharya so eloquently explained. We needed to know the medicine. We needed to really set up our public health infrastructure. So we needed to build our watchtowers and dams and escape boats to fight this tidal wave that was coming at us. So questions that were posed to us as statisticians is that, what is the projection for the number of cases? When can we expect to see a decline in fatalities? What does a successful lockdown look like? And how should we return to normalcy from lockdown? So, so when we looked at the qualitative comparison at that point, lockdown and stringent public health prevention measures have been rolled out in many parts of the world. So let us look at some countries. So this is Hubei, China, and you can see that the virus curve, there's a very strong control of the virus, and the curve turned, and even then there were sporadic cases all across China. But because the number of cases are small to a level of containment, contact tracing strategies were successful. This is South Korea. South Korea is probably one of the prime examples, though they are facing another another surge, and they're taking all kinds of stringent measurements right now as we speak. But initially they saw a peak. Their strategy was never a complete shutdown, but really extensive testing and contact tracing using data. And they were largely successful without much shrinkage to their economy. And then Italy waited to roll out the national lockdown. And as a result, as you can see in each of these graphs, the red part is the number of fatalities or deaths, and the number of fatalities in Italy was quite substantially large. So what are we seeing in India? So in India, lockdown started on March 25th, and then different phases, 6 to 8 weeks, even in June and July and August. The virus curve looks nothing like what we have seen in other countries. And first, I was very surprised that why is that not happening? So gradually we made some observation which made the situation a little bit clearer to us, the explanation a little bit clearer to us. Why aren't we seeing the peak in India? So that's probably the burning question in everyone's mind, and I'll try to allude to our hypothesis and explanation of why this has happened. So models, forecasting models, so there are many, and the number of models probably grew as exponentially as the virus itself. And I'm just listing a few models here, but there are many more in the last few weeks, last few months, and about 40,000 coronavirus papers on PubMed, so nobody can claim that they have read them all. So the model that we used, that it's a SIR model. These are nonlinear compartmental models. And the 3 states are susceptible, infected, and removed. So these are traditional epidemiologic models, very well known, very well characterized, and it can model the transmission of a virus. When an infected person meets a susceptible person, then how does it get infected? and then also builds into the removed part, which is a composition of recovered cases and fatalities as well. So in what the data that is released from each of the country gives us counts from for the number of infections, but the number of reported infections is all that we are seeing. So we are only seeing the tip of the iceberg, and as we all know by this time, asymptomatic infections are key to this mystery of the coronavirus, and how can we get track of that is something that we are going to talk about in the third part of this talk. So the true proportions of each of these in the population who are falling in these compartments is largely unknown because we are seeing only the reported data here. So the question is that what they really are, and how can a stochastic modeler try to predict these unknown proportions with uncertainties characterized around them. So what happened was that it was really a remarkable coincidence that we used an extended version of this SIR model, and my colleague Peter Song and his students in Michigan had already developed this mathematical tool for Wuhan analyzing the data in China. So we simply at that point borrowed that tool, and the whole idea was to build a Markov process where you have the latent counts of the true counts that we are not getting to see. This is the what is beneath that tip of the iceberg. We try to model them as statisticians based on why or what we are seeing the data on the ground. And we'll come to what data is reported, data anomalies, and data inadequacies in the end. So then based on this, we try to project what is the future. If we have seen this in the past days, what does if we have seen day t, we have seen day t plus 1, what does day t plus 2 or t plus 10 hold for us? And I know that this is not a purely statistical audience, so I'm not going to talk about mathematical equations, but I'm just going to give you a crux of what we did at this time to just convey the main notion and the conceptual paradigm. So interventions, what does an intervention do, and how does a modeler model an intervention and think about an intervention? So if there is no intervention, there would be a completely full reign of somebody, a susceptible individual meeting an infected individual. But through intervention, you'd like to really reduce transmission or this probability that an infected person can meet a susceptible person. So that's where the transmission intervention comes in through social distancing, mask wearing, so that the virus cannot travel freely. So stochastic modeler will translate that intervention, the public health intervention in terms of language, into a probability or a pi t, and try to guess how much will this probability of transmission going to reduce if I wear masks, or if there is a lockdown, or if we ban large gatherings, or we shut down the borders of India. So it is all conjectural in terms of a probability to a statistician or modeler. So when we did this model, we essentially wanted to reduce the probability. We conjectured and made hypotheses about this probability. So our graphs that we presented in our papers always looked like this, that we are standing here, but we are playing pretend. We are playing pretend that if we actually, after the lockdown, people had cautious return, or if they were overzealous and got back to normalcy without thinking about these precautions, or if this was a moderate return, that those all scenarios are actually hypothesizing a value of that probability, saying if you wore masks, if you actually washed your hands several times, if you actually did not go to large gatherings, if we adopted all the precautions as a community, what would that pie look like? How much reduction would you have? So you have to understand the limitation of these models is that we never know what is going on in practice. We can only conjecture, and that's why a statistician, to everybody's dissatisfaction, cannot give one single number or one curve. We have various different curves or scenarios. And in mathematical modeling work, we also compared the length of the lockdown, that how much we all know that if we could have perpetual lockdown, obviously the virus curve will probably go down theoretically if a successful lockdown. but it is not feasible. It's not feasible for humanity to be under perpetual lockdown, and we have seen that all across the world. So how much is feasible? So our mathematical models also compared a 3-week versus an 8-week lockdown by again fudging with that pi probability that how much will transmission reduce. So that was the key to these models. And one quantitative thing for those of you who are joining with a data science and statistics background that I learned, which I think is the key takeaway earlier on, was that we saw that the models really cannot be static. So you cannot take a traditional academic perspective that I did this model, I wrote the paper, I submitted it, and I'm done. So you have to continuously work on this problem, and that was the challenging thing. And I'll show you that in April, when we looked at the models, we saw that if we actually use data up to April 1, the models are not so close. So here in this graph, I showed the observed data in terms of gray bars. And we saw that if we update the models continuously, if we use more and more data and calibrate and train the models, the predictions become more accurate. So that's when we actually talked with our university and said, we need enough computing space so that we can run these models every night so that the predictions become closer to the truth. So again, as I said, that these models are run every night, and you can see our projections every day on this site. Then phase 2, as I said, we were not being able to see the peak of the India curve. So what is actually going on? And at that point, with collaborating with Dipankar Basu, who is an economist at University of Massachusetts Amherst, we realized that India is not a homogeneous system. So it will be really, really hard to see the national peak in India because there is so much state level heterogeneity in India. And we see we need to really build state level models, and you will see a cascade of peaks. So initially it was Maharashtra, Delhi, Gujarat, but then the virus moved with the mobility of the migrant workers. It moved to the eastern regions. So you will never be able to see a pronounced peak in India unless most of the states, large populous states, come to a state of containment. So that was a very interesting observation that at the time, so for example, this is the virus curve in India, but you see that different states have different patterns. So Punjab has this pattern where there's a small peak and they did an effective control, but it soared back again. And Maharashtra is very slow and steady, slowing down, but still growing. Delhi seems to have a pronounced peak and come down, but now they're facing challenges again. I'll show you. So it's not a static system, and it's not a homogeneous system. So we really needed to look at a state level model. So our second paper actually really focused on each of the states and built state level models. And we made the observation that the national data is masking state level variations. And over the next 2 months, standing in June, we said July and August, we are going to see a cascade of peaks because different states are sort of coming to boil at different points in time. And so what has happened? Has the lockdown then been effective at all? Did we all stay at home and hunker down for nothing? So I'd like to say that the lockdown was effective in slowing down the virus. So this is a curve of the basic reproduction number over time, which is the effective reproduction number. And you can see in this on the left-hand side of this plot that prior to the lockdown, it was around 3. And after the lockdown, it has gradually slowed down, but it has never really gone below unity. So right now in India, I'm going to show you the national data, the R is around 1.1. So it has slowed down the virus. But then different states also have different features. So we have to look at India as a constitution of a constellation of different states. And that was an important observation. With that in mind, we created a dashboard where a healthcare worker or a policymaker can go and see where is my state now. So we have ranking of states in terms of different public health metrics. So for example, so this was our dashboard in the website on June 15th, and Delhi looked quite bad at that time with an R well above 1 and a short doubling time. So again, we present a plethora of metrics there. But then as we move into August, we see that Delhi has done a good job, as you saw, that they ramped up testing and really enforced public health interventions, mask wearing, and then they were able to change things, and the doubling time increased and the R came down. So it shows that the public health interventions can be effective, but it's really, really hard, because now the people of Delhi are getting tired and you are seeing more cases again. And that's what is happening with the virus. And that's why success looks so tenuous here. So this was Delhi on June 15, and it looked like the projections were really dire. The health minister came out and said that we should really brace ourselves for a very grim month. But then in August, by the time you can see a clear peak and decline. But we have to keep at it. That's the hardest part, to keep at it at the cost of a lot of other additional costs that we are incurring. So current predictions standing, and I know that many of you are probably interested in West Bengal as well. What are we seeing? Are things slowing down? The things are slowing down, but it's a relative slowing down, and India is going to continue to have, if you go to 80,000 cases per day, you cannot get down or get to, it will take some time for the curve to come down. And again, it's very hard to predict the peak in India because of different states. And now we see that the virus had spread to rural areas as well. So this is some of our predictions. And again, you can see that you can get these predictions from our website. So in July and August, so this was the first phase. I described the first phase, the initial work, the second phase, characterizing this state level heterogeneity. I want to talk a little bit about the third phase of the work, which is more mathematical. And I think for me as a statistician and as a student of mathematics and statistics, and with my ISI lineage and presidency college lineage, this part has been the most interesting. So on July 20, there is an article in New York Times, because this is unprecedented. I mentioned to you that the Medium article is not peer reviewed. We are really doing very rapid science, and we are at high risk of making mistakes. And you have already seen that so many times recommendations have been revised with respect to medication, with respect to projection. That's because we are not used to this pace of science. So this was an article by a famous statistician from Stanford and a famous computational biologist from Berkeley about this risk of preprints, like our Medium article. Who is checking? And if national policies and human life is dependent on this research, what are we really doing as a scientific community? And that morning, I still remember that one of my friends actually called me and said that, oh, your name appeared in this article. And I saw the name of this article and I said, oh my God, somebody must have found a problem with the models. I'm really doomed. But to my greatest surprise, and this will probably remain the most significant reward of this whole process, that the peers who are data scientists really commended our work for its rigor and also nimble timing. So I think this is the key that you have to do. You have to strike a balance. A perfect cannot become the enemy of the good, between how fast you are doing the work and with what accuracy you are doing the work with massive amounts of data and rush in time. So then the next part actually is very strange, that this idea of connecting seroprevalence surveys to and herd immunity is India pursuing. Like, you saw many of the sero surveys coming out and everybody is saying that we are very close to herd immunity in India. So I'd like to talk a little bit about that. And this idea about this model and this work actually came into being for this paper as I was having my interview with Karan Thapar, which is incredible. But Mr. Thapar pushed me. Mr. Thapar pushed me to answer questions that I was not comfortable answering. But that Saturday after the interview, I kept thinking about the seroprevalence surveys and how to really interact, how to really integrate the different tests that we are seeing. And Professor Bhattacharya also alluded to these tests. How do we reconcile these models with the different kinds of tests? So this Delhi Sero survey was released, and 25%, 23% at the time, and now with the most recent data, 30% people had already been affected. And so we are not seeing many cases here, and most of the cases are covert infections or silent infections. And so there are two tests here, the RT-PCR test, and this test, the current test actually has a very high false negative, and then the antibody test, which is a sign of past infections. And so so the serological surveys are doing this green test, which is actually detecting past infections. So timing is very key, because it is important to keep doing it, because seroconversions happen and things change. And the diagnostic tests have been limited because of the technology and the lab work. So that's why you cannot really make the test available and test everyone in the nation. So how do you really think about these two tests, and particularly the false negative? If you're getting a negative on this RT-PCR test, 30% of the times it's false. That means that you have a false assurance, and you're probably going out and mingling and not having a false security when you are in fact infectious. So working with two students, Ritik and Rituban, in ISI Kolkata, who are supposed to come to Michigan for their summer internship. And like all of us, this whole world has come to a stop, and they could not come to Michigan. But as a statistician, as you know, that if you have a problem that you cannot come up with an exact solution, you always try to do an approximation, a first order approximation, a second order approximation. A statistician really never gives up. So this was our approximation to their summer internship, and they did some incredible work to come up with a model which actually takes into account the false negative and symptom-based testing of the test in order to give accurate predictions. So we call this model SEIR fancy, because it takes care of the false negative and the symptoms. And so from this model, what we actually, the model without the sero surveys, we said that in India, the underreporting factor for cases, particularly this is for Delhi, was for 30 to 40, 1 out of 30, 1 out of 40 cases are detected. And we also said that the underreporting of deaths is also going on, and our estimated factor is about 8 to 13. So fortunately, we could verify the first observation from the models, this underreporting, through the sero survey, which also was largely consistent that 6 million people in Delhi already had the infection, and Delhi is reporting about only 170,000 reported cases. So that's very consistent with what our model is telling us. So that was a very interesting moment for us to reconcile the epidemiologic models with the sero surveys. Unfortunately, I cannot verify the death data or cannot prove that death underreporting is going on at this level in Delhi. But even if you assume that this level of death and fatalities are happening, the encouraging part, and you have seen this in the media and talked about many times, that the infection fatality rate in India is still small. So it's 0.1% if you believe the reported deaths. If you believe that underreporting is going on, it's 0.8%. So even if I believe that, okay, there is no additional death that are happening beyond what is being reported, if you pursue herd immunity, and if you allow 50% of India to get infected, then we'll have 670,000 deaths. And maybe this is small. This is a very small percentage of the population, but when every death is the face of a loved one, it's not a statistic anymore. So I feel like every death is preventable. And if we surrender to destiny and take a fatalistic approach at this point that we cannot do anything anymore, that will be not the correct strategy, in my opinion. So where do we stand today? We have 3.85 million total cases. We are about to take over Brazil and claim the second place in the world. We have 800,000 active cases. So basically, there is no doubt that community transmission has happened, because you cannot trace back each case to its source. About 67.5 thousand deaths. 44 million tests done. This is very high in terms of the context of the world, but India is very large. So it's like about 3.25% of the population, compared to US, where we have tested 25% of the population. The test positivity rate, it stayed at 4% for a long time in the beginning period during the lockdown, but now it's 8.7%. But the assuring thing is probably this case fatality rate of 1.8%, which is lower than other countries. So again, where do we stand in the top 3 countries? So this is the United States. As you can see that the second peak was higher than the first peak. I do not think this is a second biological peak. It's again the state level heterogeneity in US that played out, that the first set of states in the coastal areas and then the middle of the country got infected. Very similar phenomenon as India. This is Brazil. And again, you see this periodicity, but that's due to reporting, and they don't report much in the weekend. So that's why you see this cyclical behavior. But it is coming down in Brazil. And this is where India is. So very slow growth, but still climbing up. So one thing I'd like to point out that, this is the race to the million graph. India's first million was very slow, and that could be due to limited testing, national lockdown, but the second million came in 21 days, the third million came in 16 days, and the fourth million we are about to hit. So we are really rapidly growing. And then again, this is in terms of the number of reported cases only. I also want to show you how the landscape of the cases change from time. So the first million, I have plotted in this pie charts, the first million, the second million, and the third million to show you how the case distribution changed across time. So Delhi had a large share in the first million, but you can see that West Bengal popping up as a share in the top 7 states in the second million and in the third million as well. So, and Maharashtra, though it is a smaller slice of the pie, and Mumbai has been slowing down, but there are other parts of Maharashtra which have warmed up since then. So this is the situation, and you can see that whole hypothesis that we said that in May, that the disease is moving to the eastern areas, and you can see West Bengal and Bihar taking 5% of the cases in the last 2 millions. So this is the snapshot of a table that we produced. And again, through this whole process, we realized that communication with policymakers is incredibly important. So this table is a part of our app. It gets updated every day. And it's a 1-page summary that you can look at without going through the incredibly rich numbers that everybody's producing every day, where you have the national R, or the reproduction number, the doubling time, the case fatality rate, the test positive rate, the total number of tested. And we also created a metric that ideally, how many more tests could you have done? And I know that, I can sit here and say that you should do 144 million more tests, but that's not going to happen. So what we can do as alternatives is something we need to think about. So, particularly West Bengal, I'm sure many of you are interested in knowing about West Bengal. It seems like from the observed data that there has been a slowdown of cases in West Bengal, but still we are predicting a slow growth until this is projection 3 weeks out, and 8.6% test positivity rate. So is this new? I really have done a lot of studying of the history of pandemics, and there are wonderful novels and wonderful literature on this. I'd like to really point out this one graph. This is from 1918 Spanish flu. This was much, much worse for India. 5% of India's population died in the Spanish flu. According to historians, this Bombay fever claimed 12 to 19 million lives. And as a result, there was a reduction in birth of around 30% in the following years. So the consequences of a pandemic are quite severe, and it's a long-term consequences. But one thing you can see, the thing that we observed here, some things are eternal, that you can see that the first peak was in Bombay, it was much higher. And then the second peak was in Madras, which was again a time lag. And then the cases are moving. By the time it came to Calcutta, you can see the peaks are much more muted or subdued, because people figured out strategies for social distancing and wearing masks. And this is some recommendation for Spanish flu from 1918. And you can see every recommendation is still true. Wear a mask, live a clean, healthy life. And the final one thing, which was actually very interesting to me, because we have seen a lot of controversy in the media: do not disregard the advice of a specialist just because you do not understand. I think that's something which has come up many times, that what are these modelers saying, what are these physicians saying, but do not disregard the advice of a specialist just because you do not understand. I understand that it is a long haul. We are all tired. Whatever the statisticians say, whatever the public health professionals say, we cannot really follow them. But I do think that after 1 year like this, we really need to talk about the mental health and the humanitarian aspects. We have to have more focus in our discussion. And we also need to quantify, due to this pandemic, due to the fear of virus, what is it doing to other diseases and the delay in care from other causes. So as a recommendation, moving forward from numerical data to strategic vision, I think that we all need to manage risk in our daily lives. Some things that we did not want to do in May and June, now we are at the brink of, like, our patients, and we are managing our risk and we are doing those things. We are seeing family and friends outside in small groups, and we need to do that for our sustenance. And we cannot live a life like this for 1 year, 2 years. And in scientifically, I think we also need population-based periodic longitudinal serosurveys. This has been incredibly important. In the Pune serosurvey showed 51% people have been infected. And then we also need, one thing I think we are neglecting is what is happening to the people who we are declaring as recoveries. Other research have shown that they have anomalies of the heart and several other complications. So we really need a national follow-up cohort of every recovered patients that we have been able to catch in the system. When they're coming for plasma donation, maybe we can set up a mechanism to get their heart checked and certain tests done, so that we have good track, we have a grasp on the pulse of what is happening in terms of adverse outcome. In high density areas, I think it's important to think about centralized isolation, quarantine, because most of Indian households are highly congested and it's very hard to do self-isolation. For a government, I think it's a really very challenging time. We can criticize all our policymakers, but it is, everybody is struggling. But we need to get used to the pause, push, and drive mode of adaptive decision making, where we have to escalate policies that are working and shut down things which are not working without thinking about our fragile egos. And I think data is very key. India has had a data deficient environment in health, and that's really, really hurting us, not just to project the future, but actually to estimate the need and how many PPEs do we need, how many ICU beds, and also to characterize that historically at this time, how many deaths would we have seen from other causes? 22% of India's death are usually reported, and a large fraction is not medically reported. So how are we going to be able to compare whether this year has seen excess deaths or certain causes, death due to other causes have gone up? The cause of death is severely misclassified. So again, I mentioned that we are really neglecting the mental health and the humanitarian aspect of it. And sometimes, and as it was mentioned, my father is an actor. I grew up in a very liberal arts environment. We have to, as a community, talk about what does it mean to be a human being in the middle of a pandemic? Not just be a statistician or an economist in the middle of a pandemic, but what does it mean to be a human being in the middle of the pandemic? And we have seen that, there are several things that have happened. And I'm going to show you a picture of Dharavi. And the people of Dharavi, you can see women, they're all wearing masks. These are not N95 or KN95, but they are wearing them. There is a temperature check because we cannot get everybody tested. So syndromic surveillance and giving PPEs to the health workers so that they can do their work is extremely important. We are 6 months into the pandemic. We have to make sure that our frontline health workers are safe and secure. And then, of course, Cyclone Amphan hit West Bengal. How do you do social distancing in the middle of the pandemic? So humanity is really facing with a lot of challenges right now, and unexpected challenges coinciding with the pandemic. But are we going to give up? But I don't think we will. And again, that's when the role of art comes in, because art uplifts our spirits in a way that science really sometimes cannot. And even as a scientist, I say this, and I look at this man walking in the middle of, like, cyclone Amphan in the streets, and it's just an image of how resilient, vigilant human beings and human souls are, and how triumphant souls are. And I'd like to quote the Austrian poet Rilke, saying that let everything happen to you, the beauty and the terror, just keep going. No feeling is final. Even when we are very sad and at the bottom of our, we feel at the end of our rope, we know that happiness is around the way. When we have been happy, we have had many great moments. And then we know that something bad could happen. That is the cycle of life, and we just cannot give up. And so for the past few months, or to end on a more humorous note, for the past few months, I feel like I have been listening to a quartet in the media, in the newspaper, in my own work, the government, the public, the scientists, the virus. And they're not always in harmony. So you can see this antique cartoon from exactly 100 years ago in 1920. And I feel that sometimes people will lose a tune or two, but this is a cataclysm, and we have been very blessed as a generation, and we are facing a defining crisis, and it is important that all of us contribute in our own ways. So many people ask me, why did we do this work? I live in Michigan, and US is terrible at managing the pandemic. So why didn't I actually model the India data? Why did not I model the Michigan data? Why did I want to work on India? So in March 16th, when all of us were stuck at home, the two people that I thought about were my parents. And so this is my working desk. You can see some artwork by my daughter. And this is the boombox, which plays Rabindra Sangeet all the time. And these are my parents. So this was my way to repurpose my anxiety into something meaningful. But I did this work for my parents. And so I am waiting to go back to India and to Kolkata and be reunited with my family. And so we are all in this helpless situation. We are all human beings and scientists trying to contribute in whatever possible way so that our loved ones, the people of the world, stay safe. So thank you for listening to me. And I must say that there is a poet, I quoted Rilke, but there is a poem in Bengali that I'd really like to say, that Jibon kobhu phuroy na go phuroy na, note gachti buroy kintu muroy na. So with that hope, thank you very much for your attention.
Thank you. Thank you, Professor Mukherjee, for your in-depth study as well as discussion of different strategy of lockdown in case of India and different models, considering very unexpected challenges. Thank you, madam. Now, I know you have to leave now for your other assignment. If you give permission, may I take one or two questions, please, madam?
Sure, absolutely.
Okay. Now for questions session, please over to Srijit sir.
My
Please.
video is stopped by the host, I think. Just I am asking without the video.
Okay. Just now visible. Now you are visible, sir.
Thank you, Professor Mukherjee, for this highly illuminating talk. I feel the viewers were glued to their laptops and mobiles to listen to this talk. This is evident in number of questions we have received, but due to time limit, I can take a few of them. The first one is by Ashok Nath. Is your model can give us any idea about when there will be COVID-19 infection peak value?
Yeah. So this is the tricky thing, and I have been talking about this, that it is very hard to predict the peak, and it is very challenging. And we do see the peak for different states, but it's very hard to. So if you look at the national curve, it's almost in a plateau, because it is, if you think about mathematically, there is a virus curve, and which is predictable in a local level, but the national curve is really a mixture of the different curves. So unless we see the containment, and unpredictable things are happening, unless we see the containment, I'm quite skeptical about long-term projection from these epidemiologic models, including our own. I am hoping that after we hit the, we are going to hit the 4th million very soon. But 4th to 5th million, that's when I expect that things are going to slow down. But we are already at a level of 80,000 cases. It will take a while for the things to come to containment. And each state in India will have to come to a level. I really do not have a good grasp of what is happening in rural India, because I see that the data indicates that it has spread. So it's very hard. I feel like everything that I say would be incorrect, and we are flying blind at this point without having enough data. And that's why I insist sort of on the population-based set of prevalence studies, so that we know what's happening in some of the less known hotspots and all across India. So thank you for the question. I apologize because I cannot give you a good answer.
Thank you, ma'am. And next question is from SK Das. Can it be said from Sero survey that community transmission is going on in India?
So if you think about, that's a great question. If you think about the community definition of the textbook epidemiologic definition of community transmission, so the community transmission means that when you have cases to which you cannot attribute, you cannot identify the source. With 800,000 active cases, if somebody tells me that we know where each case got its infection from, we can map it back, I really, as a statistician, do not believe it. And I do think that even without sero surveys, we knew for a long time that community transmission has happened.
Thank you, ma'am. And the last question, this is that you told that the R has been slowed down to 1.1, but
Yes.
how much it was earlier during the March, April?
Yeah, so just prior to the lockdown, it was about 3.3, and I tried to show that. And then it came down to about 2.2. With each lockdown phase, there has been a decline. But we have to remember that R is a relative measure. Sorry. Sorry, I have a phone call. So, so R has been, like, it's a relative measure. It's not an absolute measure, because we have so many cases. Even a small percentage of, R being 1.1, because we have so many cases right now, is still going to give you that steady dose of like 80,000 cases. But it came down from 3.3, then to 2.2, and then 1.6. But over the last 1 month, it has stayed around 1.2 to 1.1. We really need to get it down closer to unity and below unity.
Thank you, ma'am, for these comments. Thank you, ma'am.
And again, one thing I'd like to again reiterate, that you see that this is very challenging particularly for the example of Delhi. The R actually stayed below 1 from 0.76 to below 1 for a period of 5-6 weeks. Now it's getting back up again, because now there is a lot of interstate mobility, and also people are giving up on the mask wearing, on all these habits. So that's why you see it's very hard. Like, this is a very challenging virus. We have to have respect for the virus. So you can see the R has gone back up to 1.3 again in Delhi. So we really need to keep at it till the scientists get to the vaccine or treatment, and where there has been tremendous progress, and I'm very hopeful about that.
Thank you, ma'am, for this hope. We are extremely hopeful that we will come out from this situation. Over to Chandanda.
Okay, thank you, Srijit. Thank you, madam. And now
I'll actually really also want to mention one thing about the contribution of ISI Kolkata to this project. Most of the students in Michigan who participated in this work have had their training from ISI Kolkata and Presidency College and St. Xavier's College. And the students who are working now are also very much based in Kolkata. So we all came together to do this work. So for that, I feel very grateful.
Thank you, madam. Thank you for your time and for illuminating us. And now the session is open for question and answer or interaction. Professor Pranab Bhattacharya is here. We have received lots of questions to Bhattacharya.
Okay, am I audible?
Okay, yes, sir. Over to Srijit. Just take only 2 questions. One from YouTube and one from Zoom platform, please. carry on.
First question is that why type 2 alveolar cells are more affected than type 1 cells in COVID positive patients? It is asked by Joita Khana.
Because they have got the adhesion molecules, which I told that adhesion molecules for the virus are present mostly in the type 2 pneumocytes. Much over the ACE2 receptors, which are present on the type 2 pneumocytes than type 1 pneumocytes.
And the next question is, in cancer treatment, we use chemotherapy. Is there any possibility that drug scientists will be able to produce similar type of therapy in COVID-19 also?
Actually, the problem is with the cytotoxic T cells, which actually release all the cytokines, all the cytokines, then interleukins, NFKB, all these things are released by this cytotoxic T cell. So any drug that causes immunosuppression that can help to overcome these cytotoxic T cells. Anti-cancer drugs are not active to the replication, to prevent the replication of the virus. Certain drug, anti-HIV drug was used, that is ritonavir and lopinavir. But these two drugs later on found that they are not able to stop the viral replication, and they are not much effective. When large meta-analysis study was done, that ritonavir and lopinavir was not much effective to progression of the lower group to moderate or moderate to the severe pneumonia group. The drug which are now used are remdesivir. Now, remdesivir is a drug which shows some sort of successful in the treatment of the COVID-19. Now, remdesivir is actually antiviral drugs, and the action of these antiviral drugs is on cutting the signal transduction for the activation of the RDRP genes product. So that is one important thing for the treatment of the drug. Second is second drug, which is flavipir. Now that is also acting on the replication of the virus. So in that case, no anti-cytotoxic drug, anti-cancer drug, nobody has tried, and nobody has used this anti-cancer drug in the treatment of the COVID-19 till date.
Thank you, sir, for your extremely informative talk and these answers. Over to you, Chandana.
Thank you, Srijit. Thank you, Professor Bhattacharya. Now, this is our formal. We are just at the end of our program, and a formal activities is there. Only vote of thanks. For vote of thanks will be given by our Teachers Council Secretary, Dr. Arun Kumar De. So, Arun Kumar Rai, please.
Can I leave now?
Hello.
Yes, sir. Yes, sir.
Okay.
Please stay with us for 2 or 3 minutes only.
Hello.
Hello, Arunda.
Am I audible?
Okay.
Am I audible?
Yes, you are audible to us.
Carry on.
Respected Vice Chancellor, WPSU, respected Principal, Barasat Government College, respected distinguished speakers, my esteemed colleagues and students, and respected participants, good evening to you all. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of myself and also on behalf of the college, extend a very hearty vote of thanks to all of you associated with this webinar. At the outset, I express our gratitude to our Honorable Vice Chancellor, Professor Barasat for accepting our invitation and also for delivering the keynote address Thank you, sir, for your interesting, inspiring, and fascinating speech. Next, I would like to extend our thankfulness to Professor Pranab Kumar Bhattacharya for taking out valuable time of your busy schedule in combating COVID-19 from the front. Your lucid presentation on SARS-CoV-2 from the pathological as well as clinical point of view made the audience captive. With your long experience of teaching medical sciences, you presented an insightful speech. Thank you, sir. I would like to mention our deep sense of appreciation to Chair Professor Brahman Mukherjee of Michigan University for presenting the invited lecture on the lockdown and COVID-19 in India from a
মা হয়ে গেছে, এটা বন্ধ